Hey everybody, Jason here from AVPro Edge, and it is Monday, and I have to say, a slightly bittersweet Monday. We've been dealing with the Audio Expert Series now for, gosh, a few months, and we've done a lot of sessions with Anthony Grimani. Hi, Anthony, how are you?
I am doing well, and yourself, Jason?
I'm good. We've spent so much time together. I've had a ton of fun. We've learned how to pick out speakers, how many you should get, where they should go, where your subwoofer should go, how many of those you should have. And at this point, we've really covered how to set the room up and how to get the room ready to go. But like in video, there's still one last step. We have to tune it. So this is actually going to be our very last episode in the Audio Expert Series, and we're going to talk specifically today about audio calibration in home cinema. Now, I hope you guys aren't being too heartbroken by this. This doesn't mean that our time with Anthony is done. In fact, we're coming up with some cool ideas to continue the series and to do some more stuff in the future. So I'll actually talk to you guys towards the end of the presentation here to toss around some ideas and see what you guys think that would be interesting for you to learn. So with that being said, Anthony, let's learn about audio calibration in a room.
I've heard people talk about audio calibration as the icing on the cake, the cherry on the top of the sundae and all that stuff, and it's not. It's a really, really important part of the process. I hope you guys have noticed that through all the sessions we've done together to date, there's sort of been a progression from initial design, like, you know, how do you figure out what the room needs to be, figure out what the speakers are you need to pick, what acoustical treatments you're putting in there. Although the order of the webinars were not exactly chronological, they sort of went through design and thought process, and now it's the last step. And this last step is extremely important. I've done about 1,000 rooms now, formally in this current implementation of my career, and done probably about 200 or 300 before that. And I got to tell you, you walk into the room after it's built and it's all great, and it sounds terrible.
Yeah.
Same thing with a video display. Best video display these days is always going to look bad, partially because the manufacturers put all these crazy giga control systems in, not control, but things to try to make it look better, and they make it look horrible. So calibration is a very, very important phase. And for me, calibration is important because it actually covers several steps that actually the British called commissioning.
Commissioning.
You go to the United Kingdom or Australia, and you'll hear people talk about, yes, I'm going to go commission this system, which the word could be confusing. But what it actually means is that you're going to go through and you're going to first check that everything works. You're going to debug all of the things that have to have, you know, gone wrong during the installation. There's a lot of wires, there's a lot of things, there's a lot of choices.
Sure.
There's a lot of ways that things can go wrong. You're going to fix them all, and then you're going to go tune all of the things you got to tune until it works right. And you're going to see in another session that most people would say, well, he's just going to talk about this for about 20 minutes, because isn't it as easy as you just push the auto EQ button, it does its thing, you go to grab a cup of coffee and come back? Well, not so.
Right.
And somewhere about halfway through this presentation, you should probably all hold your heads going, oh my God, I had no idea there's so many things I got to be thinking about and worrying about. And that is also what I do when I go to somebody's place to go calibrate it. Is like, oh my God, why are there so many things that we got to be figuring out and fixing before we can actually get this thing to work? So
sure.
This last step is, the system's been designed, it's been installed, it's been designed, it's been pre-wired, it's been installed, all of the wiring's been trimmed, everything's been connected, and now it's time to kind of get it up and running, fully check that it is actually running, and tune it. Okay. If there's any sailors in the audience, people who, you know, like these boats that go slowly, cost a lot of money, and take forever to get nowhere. The first time you get a boat out in the water, you do what's called a shakedown. That's like where you just check that everything's working, you fix all the problems. Before you do the transatlantic race, you actually check that everything is okay.
Right.
So this is the check down. quick introduction about me and what I do. So I these days I actually run 3 companies. One that makes really cool loudspeakers called Grimani Systems. One that does all the engineering, design, and calibration of rooms called PMI Engineering, and one that makes and sells acoustical treatments for the above spaces called Dimension 4 Acoustics. I have a degree in electrical engineering. I was lucky enough to spend 5 years at Dolby right out of college, young kid working in an amazing company. And then I was recruited to go work at Lucasfilm to start their home THX program. And then 21 years ago, I said, okay, enough of working for other people. I want to work for myself, which just means that now I work for 30 people at any given time, with different clients. But I've had 36 years of amazing fun doing all of the above. Let's see. I've been named top 50 industry influencer by Custom Retailer, top 20 industry personality by CE Pro Magazine. I've done a lot of designs that won CD awards. I've made the top CDA instructor a few times, and I invented Surround EX along the way. CDA member, AES member, patents, kids, guitars, saxophones. I have an airplane. My main toy, I would say these days, is the thing that lifts up off the air and goes flying around. We all have to have toys, right? We used to be boys, now we're men. We have expensive toys. That's how it is. Other toys include an old Morris car, a McLaren M8 replica, bicycles, kayak now. Actually, yes. Jason and I are both avid kayakers. We were talking about that before this started. And that's a lot of fun. So, all right. I say all this because I don't want you guys to just think this is all I do. Yes, yeah. I love doing this. I have other interests in my life too, which is what makes life interesting and fun. All right, overview of what we're going to talk about today. We're going to start off by talking about configuration. There's a fair number of things that you have to do. All these boxes, all these products come out of their cardboard boxes. They get put in the rack, and they expect you to configure them. Where they're going to verify that everything is working right. We're going to find that some things are not working right. So we're going to have to spend a bunch of time debugging and figuring out, what do we need to know at this point to make it all work. We're going to spend a whole bunch of time doing what's called here equalization. I call it frequency response calibration, but the term is EQ. And then we're also going to do level and time synchronization, which people think of as level calibration and setting the distances. It's actually a little more complicated than that. And then we're going to do a listening test. That's like, the sailboat, you take it out sailing to make sure it sails well. That's a listening test, and you ain't done until you feel like everything is working really well to your ears, so that your client goes, wow, that's really, really cool. Okay, now what's cool about this is just like in video, people who do a lot of video calibration go, well, audio is sort of vague. I don't know, it's not like video where everything is very regimented. Well, sort of. There's just a few things that are vague, and as you see, like at the end, I'm going to talk about 2 or 3 little things. It's like, well, it depends. The majority is actually quite structured, and if you have the right tools and the right knowledge, you're just going to follow down a procedure that I'll give you. And ultimately, what's really cool is there is a reference. The reference in the world of sound, especially for home cinemas, is rooms like the one you have on your screen. This is a picture of one of the mixing rooms at Skywalker Sound up at the Lucasfilm headquarters where I used to work. And that room is built on documented standards. You can read those documents called the ISO 2969X curve, 2969X document. There's also a curve called that. And then the SMPT, Society of Motion Picture and Television Engineers document 2021 tell you here's what this room should be doing. And that should be doing applies to level, frequency response, position of speakers, noise floor, distortion, all the stuff. So it's not a random interpretation. And everything that I do when I go do calibrations is to achieve proper results on these. So now I can see there's a little.
Oh yeah, I lost you for about video. I lost you for about 2 seconds, but you're back now. And by the way,
yeah, I just went to the restroom, went back and drank a cup of coffee in that time.
Real quick, I didn't mention at the very beginning. I usually do. I forgot, but as you folks are listening in, feel free. The question box is wide open, guys. So if you have questions, let's hear them. I'm sure there's going to be plenty of them this session.
Okay, so Let's pretend that you're the audio calibrator
Right.
that's been brought in to tune this room. Okay,
Mm-hmm.
that's the whole idea here is like, okay, so you just showed up, and what should you show up with? What should you expect? What are you going to look
Mm-hmm.
at? And what you're going to expect is at first this room has had a proper acoustic design. Now you
Mm-hmm.
can calibrate a room that has had no acoustic design. Absolutely, you're going to do the best you can, but just know you're not going to get as good of a result in a room that's got a lot of noise and echo and speakers incorrectly positioned and all this other stuff
Mm-hmm.
than if you had a properly designed room. And in the proper design, the speaker locations have been figured out in theory.
Right.
Theory being modeled, and like, look, all of the elements of math and physics say that we should put the speakers here, here, and here, and here. And the listener locations have been figured out. And I'm going to talk about what tools you should be showing up with. So if you just show up with your phone and says, well, I have a sound level meter in here and I have a spectrum
Ooh.
analyzer in here, you're like, no, dude, you're not being serious.
Yeah.
You either lost all your furniture and you got mugged on the way of furniture. You lost all your furniture. You either lost all your luggage on your way over here,
Right.
and you got mugged in the car because like you've got nothing else in your phone. They would have taken the phone.
Mm-hmm.
Not okay. There's a whole bunch of tools you need to be bringing with you, and I know Jason and I have talked about this repeatedly. It's like you can't pretend to be a calibrator if you don't have the right tools, and we're going to go over what the tools are here.
Anthony, I'm at a point now where you know, when I show up for video calibration, I've got one case with one meter, another case with another meter, another case with signal generators in it, and just random cables and a whole pocket in my backpack of random little adapters and little things that I might need along the way. And I've gotten to a point now where I just put everything into this gigantic suitcase, and I'm to a point where I'm just hauling around one big suitcase. With audio, are we to a point where we can carry everything around in one nice, rugged, big plastic case?
It's interesting, actually, because I spent years refining that. If you travel by plane, like I often do, and you want to meet the weight limits, it actually takes 2 Pelican cases so that they're both 40 pounds. If you travel on some airlines that limit that, with all of the right stuff. And the right stuff is listed over here.
Good.
You can bring it all down to one suitcase. You'd be missing something.
Sure.
Somewhere in here, I'm going to talk about a multiplexer. You really should have 4 microphones and a box that selects between those. And the combination of weight of those 4 microphones and the mic stands and the mic snake, the actual multi-cable XLR connector, and the multiplexer, its power supply and its cable, all of that together is a fair amount of weight. And on top of that, you add a bag full of all kinds of different cables that they can allow you to patch from everything to everything, and a little toolkit so that you can fix a few things, including a soldering iron, and not a little butane soldering iron, in the sound level meter. By the time you add up all the things over here, it actually takes 2 Pelican cases, that, those camera type of cases with the little foam inserts that you put everything.
That's not bad.
That weigh 40 pounds, And I have at times managed to like pare that down and travel with only one case and go, well, I'm not bringing the multiplexer. I'll just do all this manually. So you can do that. It just takes two boxes. It's funny that you asked. So here's a checklist of what you should show up with. First is a checklist, a form, a thing that you open up. First thing, you sit down and you open, in my case, a Word document, and it's 40 pages long, full of grids and charts and little things where I'm going to like write little notes that guide me through the process. This process is going to take you typically 2 days if you're serious about doing it, sometimes 3 days for a full high quality immersive audio system. And you're going to get lost if you don't actually have a flow sheet, an actual thing that goes, enter the data here, do this, do that, do that. And I've done it. I've done this hundreds and hundreds of times. If I don't follow my form, I will get lost. I'll stray off worrying about this, and like 3 hours later, I'll go, oops, I forgot to check the ... So I think of this as a checklist on an airplane. You want to make sure that before the pilot, puts that airplane on the runway, they've gone through their checklist so that they didn't forget to close the door. Or forget that thing called fuel.
Yeah, you might need some of that.
One of the most common reasons that planes crash, in general aviation, is people didn't have enough fuel. It's like,
Oh
Stupid.
man, should have gotten that. Do you notice too that there's a big time difference in when I get to do video, for example, if I'm doing a day mode and a night mode and maybe a game mode, it's all part of having that interview with the client to find out their lifestyle and what you need to calibrate. But what if you showed up to a house like mine where there's basically 2 listening positions? And does that simplify the system enough to where you could do a full calibration in, say, 1 day instead of 2?
Not really.
Wow.
Not really,
Okay.
because even with just 2 seat, so we talked about this last time, how big is
Right.
a sweet spot?
Right.
What you want to be doing when you're calibrating is to lay out 4 microphones around the seat positions, and whether you know that there's only 2 or 4 or 10, you're going to need to do a spatial average, and you're still going to need to
Okay.
check all of the things you got to check. So what that may save is, in the end, when you're doing a listening test and you're doing a little tweak by ear, you only have 2 seats you got to listen to as opposed to 10, so you save yourself maybe half an hour.
Fair enough.
So that is a good question, actually. So you're gonna have your test form. You're gonna have some test discs. You're gonna have some signal generators for sine wave signals and pink signals and impulse response signals. You're gonna have multimeters, impedance meters, spectrum analyzers, measurement microphones and multiplexer, sound level meters, polarity testers, which are interesting little gizmo I'll talk about later. You're gonna have your etymotic headphones, which is actually what I'm wearing right here.
Oh,
right
nice.
now. It's an in-ear, very high quality in-ear earphone, and I'll talk later about what you do with that. And you're going to have an oscilloscope, and it's like, why do you need all that? I'm going to show you. In addition to that, it's not a bad idea to show up with a little table to put your laptop on, and this thing called a chair so you can park your butt on, because you're going to be there for 2 days. I actually now have this little sort of tripod table that this laptop is sitting on. That's the one I bring with me.
Oh, good.
And I can sit down, and then I can extend the pole up and stand up a little bit so that I'm healthy and stand a part of the day.
I am. This table behind me, I take to my video calibration jobs. It's like 2 feet wide by about 18 inches deep or so.
Right.
It's perfect. Absolutely. It holds all my stuff just perfect. Something like that probably would be good for audio too, right?
Yep. And there is stuff. You need a laptop or 2. I usually actually like to bring 2 laptops. One that I'm using for my form and for analysis. The other one I'm using to do adjustments with. So you can kind of go quickly between the 2. And then there's the multiplexer and all the other tools. You want to put them down somewhere. Maybe even have a notepad that you're writing some notes on. So you're going to set up a little workstation. And that's the first thing I do when I show up, by the way, is I first take pictures of the room to document what's there.
Cool. Good idea.
Just in case, you never really know. Then I set up the workstation, open the laptop, start a form, and just start working. And if the client walks in or the client rep walks in, there's this person sitting there at like this temporary desk with all these computers and all that stuff. It's like, gee, I have no idea what that guy's doing, but it looks pretty serious.
Yep.
So, okay. Now you've taken your pictures, you've put all your equipment down, you've gotten yourself set up. First thing you do is a listening test. I just love to start to get familiar, get to know the room. So I listen to known material, listen to music, listen to films, and focus on these 8 elements of quality that I'm actually listing on my form to go, how is this working? And those 8 elements is, hey, how clear is the dialogue? How articulate is it? Does it sound kind of mushy, or does it sound like I can understand everything that's said? I listen to the sound localization, like right now. This is all pre-calibration, anything, just getting familiar with the room. How clearly do I hear where sounds are supposed to be? I listen to the spaciousness of the whole surround sound field. Am I immersed in it, or does it sound like I'm listening to a speaker here and a speaker there? I listen to how sounds move through the space. So not just how enveloped I am, but as sounds move from here to there in the soundtrack, knowing, of course, the program material I'm listening to and knowing what to expect. Is it being rendered correctly? I then listen to the tonal balance, like is there too much bass, too little bass, mids, highs, just overall frequency balance of the system. I listen for the dynamics. Does it look like we're overloading on the top end, or does it look like I'm losing little fine elements on the bottom end? And then I listen to this more esoteric thing, because is the system transparent? In other words, once I'm done listening to these other elements, does it sound like I'm listening to speakers, or does it sound like I'm listening to music or a film soundtrack? And then finally, I do that at every seat. And that is where you ask to do a 2-seat theater. It's like, well, you save a little time, but it's not like an enormous difference. So at the end of this whole thing, we're trying to get 8. We're trying to get high marks in all 8 of these things. Okay, so you could say we're trying to get to a point where the frequency response is this and the level, like in numbers, but in the end, you got to have good grades in these 8 elements. Okay, so first thing we do is system configuration. So we're done with our listening test. We've made some mental notes. Better yet, we've written down some notes. Better yet, we've typed it into our form about what we've noticed on this piece of program material and that piece of program material. And as we go through the process, we're going to listen to that program material again and again and again. And at the end, we're going to listen to that same thing again to see how we're doing in terms of progress. So system configuration. There's a bunch of boxes in that rack, and all of them just come right out of the rack, probably in the wrong modes. And so we're going to first configure the processor. Most processors today have this little journey that you go through where you configure the system, the speaker system layout. You tell them, I've got these speakers. Maybe in the case of the top speakers, for Atmos Immersive, it asks you, are they in the front, are they in the middle, or in the back? All of the above, some of the above. What size speakers do you have? How many outputs are you using? Every surround processor is a little bit different. By the way, there's a lot of ways that people call these boxes. I actually like to call them controllers because they control the input signal.
Sure.
They control how it's processed. They control the volume. They control the output signal. People often call them pre-pros, preamp processors, whatever. It's the device that's doing the surround processing, and we need to tell it, here's the system I have. Part of that system is the base management. So different boxes ask these questions differently. The menus are different. Sometimes the menus are only available on a web interface. Sometimes you have to go through a video set of menus. And by the way, if there's no video display available in the room yet, because they're still working on the projector, in many cases, you won't be able to see what's coming off the menus of that product.
A good tool to have, I think every installer should have, just period, or calibrator or programmer, or anybody who works in our field, is some sort of little test monitor like this, because we run into video systems all the time where the projector's out to service or the TVs haven't shown up yet, or da-da-da-da-da. So we have to test infrastructure. We have to make sure signal's getting there. So these little test monitors I've got back here, there's portable ones, battery-powered ones. Every installer should have something like that.
Right, or sometimes the processor is in a rec room downstairs and you're doing some stuff and you have to run back and forth as you're looking through the menu. You have to run back and forth to the room that's 2 flights up. So very good for your exercise regimen, by the way, but you're going to take forever. So you should have a little monitor. That's part of what's in my 80 pounds of stuff is a little monitor. And nothing fancy, just basic little HD.
Something you can see the picture and see the menus.
Exactly. So you're gonna tell the processor, look, I have speakers. We'll talk about what we're gonna set, but they're gonna be all in small mode. You're gonna tell it what crossover frequencies you want. Some of these products have limiters for the bass peaks and stuff like that. And you're gonna set all that up. And you're going to set up what I call time synchronization, which is you're going to tell the processor what are the distances between the speakers, each one of the speakers, and your seating position. And from that, the processor is going to go, okay, so these speakers are closer, these are further. I will put some delay on the ones that are closer so that the handicap created by the further distance is compensated and all of the sounds from all the speakers arrive at the head. Interestingly enough, you're going to set that first, in theory, by measuring. And the measuring device, in my view, is a little digital measuring tape. Bosch makes good ones. You can measure it with a tape measure. It takes longer. So that's not in my list of tools because there's a whole bunch more things you should have, but a little digital measuring tape. You're going to enter that in, and you're going to, all the way at the end, when I'm done talking about this, I bet it's going to take me 2 hours to get through this. It's going to take you 2 or 3 days, remember. All the way at the end, you're actually going to verify that this time synchronization works correctly, and I'll show you how to do that. And you're going to poke around the menus of this processor to see what other things are buried in the menus. So every processor out there, just like TVs, have menus that set all kinds of stuff that the manufacturer thought you would want. you know, in the case of TV is auto dynamic contrast and
sounds familiar.
skin tone correction to make everybody look like they just came back from a vacation in Southern California. No, you got to turn all of that crap off. Go find it, turn it all off, put it all in default mode. And I can't even tell you where to start with that because they're all different. So
oh yeah.
All right, next thing, and this I see, by the way, the number of times I go into a system that's been tuned and I can tell that nobody's gone through this, that the speakers are all set incorrectly, that nobody bothered putting in the distances to the speakers. You go like, what did you tune?
Yeah.
What did you do? I don't know. And maybe, you know, I'm always willing to accept the fact that somebody tuned it and the processor, the actual memory got lost, so it like went back to default mode.
Oh yeah.
Or that the client hit the default button by mistake. Who knows? But more often than not, people are just not going through this. Now, the other thing that I would say, you know, they say that 90% of statistics are made up on the spot. I'm going to say that 88% of the time, when I go to a system that's been configured by somebody, they have not set up the source devices. They have not told the source devices what kind of signals they should feed out their HDMI output. I'm sure you see that too, Jason, right?
All the time in video. We you know, there's a picture on the screen, and because there's a picture on the screen, they just assume that it's 4K HDR, and because the source is not set up correctly, it's the same situation.
Yeah, and it could actually be 2K, no HDR, of course.
Right.
So all boxes out there, all source devices, whether it's a Blu-ray player, remember those? You put a little disc in there, they spin, they put a really good picture, or satellite receivers, or streaming devices, whatever they are. I said this thing about Blu-ray players because the majority of clients go, I don't need a Blu-ray player.
Ooh, I hate that.
You need a Blu-ray player. Why do I need a Blu-ray player? Because I'm going to come over and calibrate this thing, and I need a Blu-ray player for video and audio. Is that good enough? It's $400. Can we get over this conversation? Thank you very much.
Yeah, no kidding.
Well, but it's like, okay, here's another reason you need a Blu-ray player. You're thinking that all movies that are going to show up on your Apple TV are always going to be perfect, or they're always going to be available.
Yeah.
Well, they're not. You should have a little collection of 5 or 10 of your favorite movies, so that when your friends come over and you want to give them a demo, you're not fumbling around trying to find the perfect demo. You've got it as a physical media, or you have a video server. So, you know, I'm a fan of what the guys at Kaleidoscape have been doing, like it or not. You know, it's not that expensive for what you get. You got to have some way to have repeatable media, and you got to be able to play a disc. So now those boxes, those Blu-ray players come out of a box, or those satellite receivers come out of a box, or those Apple TVs come out of the box in various states of confusion when it comes to what they put out to the surround decoder. And more often than not, the manufacturers just go, you know, I'm not going to take any risk. I'm just going to set the default to be 2-channel stereo mode. No matter what you play on it, it puts out 2-channel. That will always produce signal.
It'll always work.
The back end. It'll always work. And so I've seen $1 million systems in which the main source device is actually set for 2-channel stereo, and the client has been listening to left and right speakers for the whole time until I show up. It's like, wow.
Yeah.
Jason's frustrated, I can see.
It's no different than when you show up and somebody's got a really nice projector or a really nice flat panel and it's set in dynamic mode, and the poor sap has been watching it like that for 6 months before I finally get a chance to get over there. I mean, there's so many similarities with audio and video. That's why it's so cool.
Yeah, it's a similar game.
Right.
So anyway, you're going to go find where it is in that product that you go tell the thing, hey, put out bitstream audio, unadulterated, unchecked, unchanged bitstream audio over to the surround decoder. And sometimes you just have to do a checkbox, Dolby Digital DTS on. Sometimes on some products, it's a whole generation of Sony Blue Ultra HD 4K players in which there was no box for that. You set the digital audio to auto, and then in another menu you told it do not do any mixing of specialty signals. So in other words, don't convert the digital audio bitstream to PCM so you can mix in pings and dings and director's commentary. Just leave it standard.
Oh, sure.
Sony has changed that now. So now we're back to like the proper denomination, but you gotta mess around with that. And then you don't just set the thing. You actually look to see with your source device that that the decoder is now acknowledging that it's actually seeing bits.
Right.
So if you have a more sophisticated system in which you have a bunch of source devices that are going into a matrix switcher, like the ones made by AVPro, you got to make sure that the EDIDs, the actual thing that talks to everybody, are all correct. If there's
Right.
multiple outputs, one going to your surround processor and the other one going to basic TVs, the device could get fooled and turn everything into 2-channel because it's seeing the EDID of the TV that says, oh, no, I can only take 2 channels. So it changes everything to 2-channel, including the main $1 million cinema.
Right. So
set the setting of all the source devices, and then go check and see that it's actually working by getting into a menu that tells you, yeah, I'm seeing proper Dolby Digital, Dolby Atmos, whatever DTS, whatever source device you have. All right. So sorry, I talked, I didn't put up this thing. Make sure all EDIDs of the systems and switchers work, and if they have to be programmed, like the one from, I'll name them. No bashing. Crestron makes amazing products.
Oh, yeah,
amazing.
they do. Sure.
Absolutely unbelievable. But if you don't program them, they don't work right. We all know that.
Right.
And the Crestron DM or all of their matrix switchers, they come right out of the box going, everything's 2-channel. And if you don't go in and configure every input, every output to be, full on midstream, highest resolution of what you can do, the poor client's going to be listening to 2-channel. And then I show up and I try to do a calibration. I don't know how to get into their Crestron processor because it's locked down. I don't know, and I'm screwed.
Yeah, there's nothing you can do.
Nothing I can do.
I've been stuck in those positions as well. I show up to this big, crazy video calibration job, and I need to change something in the rack. And the last thing I want to do as a calibrator who did not install this system is go through and start touching things. The very last thing I want to do. And I also want to say too, Anthony, I'm so glad that you stress the importance of EDID management so much, because in our classes that we teach, AVPro Academy and the ISF course, we've added a whole section now of EDID because it's so important these days, not only for the audio situations you're talking about. Yeah, 2 channels, a nice safe EDID, so that's what it comes from the default. But also too, don't forget that the EDID on a lot of devices is also for 1080p still to this day for the same exact reason. Some people plug it in, it'll work, it's safe. Now the integrator or the calibrator has to go in and configure it, and a lot of people forget that step. So I'm so glad that you stress it.
Right, absolutely. So I've been saying through this webinar series that here I am yakking about this stuff, Jason and I are talking about it, and none of it actually relates to anything that AVPro Edge sells. And so thank you for being altruistic. So today there's 2 exceptions. I'm actually talking about stuff that AVPro does extremely well, including EDID management.
Yes.
And does so in a way that it's actually really easy to go in and set it all up. Just please remember to set it up. Okay?
Just do it. Yeah.
All right. And by the way, so here we are 38 minutes into the class, and I'm just getting started on some things that have nothing to do with tuning levels. And that's because if you don't do all of these things, everything I'm going to talk about over here, I don't care what you do later, it's not going to work. You're going to have to come back and come back and come back going, why isn't this sounding right? All right. So so far we've configured the surround processor.
Anthony, real quick, sorry to interrupt. We have a request from one of the viewers, Dan. He said, can you go back 1 screen? And I don't know if Dan was intending on screenshotting it maybe or what, but Dan, let me know what you want to do and we can move on. Or maybe he has a question. Yeah, let's see. Let's give Dan a second to answer. And Dan, go ahead and just any question that you might have, feel free to type it in. We'll keep going. And oh, he was just going to do a screenshot. Okay, cool, easy enough. Okay, cool.
Okay.
Game on.
So just remember that all of this is being videotaped. I love it when people say that.
Yeah, we're filming it.
I got to tell you, Jason doesn't have a piece of tape that he's putting all this on. He threw out the VHS machine last week. I saw it in the back over there. Now, all this is being bitted. It's being recorded. It's being transcribed onto a digital media and will be available very, very quickly after the session as a YouTube video, so you can go back and look at any of this stuff. All right, so we've configured the surround processor. We've configured all the source devices. I talked about disc players, but of course everything that's a source device into the system needs a configuration. And you need to go into the menus of the Apple device and go deep into there and set them all right. And it can get really confusing. And I don't have time to go into all of the little minutiae on this. I actually
too many. There's way too many.
A few articles on this stuff, just kind of discussed it by how hard it is sometimes to just even figure out what they mean by that menu thing. So
What does it mean?
try something, test it, and it's like, whoa, we got to tell the world.
Mm-hmm.
So next up, you got to configure the amplifiers. I'm assuming, by the way, in this session that you've got an upper end system where you got source devices that maybe are going into a switcher. The output of that's going into a surround decoder. The output of that's going into a bank of equalizers. The output of that's going into a bank of amplifiers, and the output of that's going to a bunch of speakers. And we're going to check all those things. So the amplifiers, you need to set their gain if it's adjustable. Some amps have an adjustable gain. If you don't know where to start, I always go to what's called 29 dB. That's a great start point for most amplifiers. You're going to set whether you're going to use bridging or not. You're going to set the bandwidth. Some amplifiers, actually amps, especially that come out of very good quality, very audiophile amps, but that are sometimes using commercial and pro audio, they sometimes have a filter to limit low frequency, turn that off. And then some amplifiers have grounding switches on them. If you're running things balanced or unbalanced, you want to select which one results in less hum. Configuration of speakers. You go, what do you got to configure on speakers? Well, some speakers actually have a boundary compensation. They have a switch or different inputs for whether the speaker is actually up against a wall or in the room that changes their low frequency gain. Some speakers can run by wire, where one set of wires is going to the tweeter, one set of wires is going to the woofer. Some of them it's really bi-amplified, like on our speakers, like these things back over here. There's no crossover built in. You got to make sure that you're going into the right inputs.
Ah, yes.
But some of them actually have little connection strips if you're running single wire by wire. So I've seen a lot of systems where somebody bothered putting two sets of wires for low frequency and high frequency, and then the little connection bridges are still on. It's like, well,
wait a second.
That's too bad. It's still better because you run more copper from here to there, and it's all about lowering the resistance, but it would have been better if you could actually isolate those two things. And you're going to check the low frequency extension of the speaker. So this is a thing that at this point may need to be configured, may need to be checked. I'll talk about this later, but in order to decide where you're going to set the crossover of your surround decoder, you really need to know how low the speaker can play. And most manufacturers aren't really going to tell you exactly in their specs what that is. This is a point at which you need to do this. And I'll get more into that later, but somewhere along here, you need to configure that. With surround speakers, if they're a point source, if they're regular, woofer tweeter speaker, there's nothing to set in the dispersion. But if they're one of these speakers that has a bunch of drivers in there and switches and connectors that can choose whether it's a point source, a bipole, or dipole, this is the time where you need to set that. I did a whole session about what are the right speakers to pick for each room. Go look at that to figure out what's the right mode. Ultimately, you're trying to balance the spaciousness and localization. So a dipole speaker is very spacious, maybe too spacious and not localizable enough, depending on the room size. And the converse is true. A regular front-firing speaker or a configurable speaker in point source mode may call attention too much to it, so that every time there's a surround effect, you hear it from there. You need to listen for that. On subwoofers, if you're using active subwoofers, which I hope you are, there's often a gain knob, a crossover knob, and a polarity switch. The gain, if there is a fixed position, which is either known as sometimes called the LFE mode, sometimes the THX position, whatever it is, just set that gain to the fixed position. Sometimes there's a switch. If you leave a knob active when you can defeat it, your client's going to show up and turn it up, and then going to go, oh, it's a lot better. And then they're going to wonder why the dialogue's unintelligible because it's bathing in low frequency. If there's a crossover setting, either turn it off or turn it to the highest frequency possible, because you don't want that to interfere with the selection of crossover in the surround decoder. And if there's a polarity switch, start with 0, or sometimes it's called a phase knob. You set that at 0. You can't change the whole phase of the subwoofer; it's impossible. But what they mean, actually not with the technology that's in a active subwoofer, but what they mean by that is right in the crossover region, they can actually do some phase rotation to help align the subwoofer to the main satellite speakers in there. All right, so believe it or not, if I had more time, I would go on with another 10 slides of all the things you need to configure before you can start doing anything. And that would be the subject of a 2-day-long course on calibration. Jason and I were talking about the fact that, hey, are you guys interested in extending this? Are you guys interested in sitting through I wouldn't do this all in 2 days, but it'd be 2-hour modules on calibration. And if you are, just let Jason know. We're looking at, hey, can this thing be extended into a 16-hour course for about $50 per hour? Is that what we were talking about?
Yeah, we were trying to come up with a way for you guys to get more trained and more education and deep dives and talk about some actual, a lot of the stuff we're talking about is theory and perfect world scenarios, but we're thinking of some ways like what we do with video and doing some small modules with deeper and more advanced education. So if you guys like the idea of that, feel free, shoot me an email, let me know, and if we have enough interest and enough of you are thinking that you could benefit from that, then it's certainly something that we would love to do for everybody. So
Right.
feel free to hit up the question box, the chat box, email me, hit us up on social media. I mean, any way you want to let us know, definitely let us know.
What would be really fun is if I could actually do some of these sessions from a calibration site sometimes. Like, here I am here, and I just show what's going on.
We've done them with video, and I think there's some really creative things that we can do nowadays with video chat and stuff. I don't see why not. If you guys like that, then please let me know, because it's something that we would love to do. Honestly,
Right.
I would love to put on something like that, but if nobody's interested, then there's no point. So you guys got to let us know if you want it.
Great. Okay, so we have shown up, listened to some program material, taken a bunch of pictures, put our equipment down, got it all connected, and started to go through menus of all these different products to make them configured, or gone to switches on speakers, amplifiers, etc. Now, do we think everything works? I guarantee it's not. I guarantee that, because what we're talking about is multiple source devices into switchers, into surround decoders, into EQs, into amplifiers and speakers, somewhere along the way there's either a product that's not working right, or there's a connection mistake. And no judgment. If like I said, I've been doing this for a while. You asked me to put together a whole immersive audio system with 11.4.4 speakers. There will be mistakes. It's like, I write a lot. I write in a lot of magazines. Every page of text I write has 3 typos in it. It's normal. But what's not normal is to not catch it. What's not normal is to put out a page of text in a magazine with typos. And I see it once in a while. And it's like, wow, was the editor asleep at the wheel here? What's going on? So This is the time where we're actually verifying the typos. So what I like to do is like this very, what do I call it? It's this very proceduralized series of steps. So I didn't bring this up earlier, actually, but at some point, right around now, you should also do what I call roll call, which is to put on a test disc. My suggestion would be the Dolby Atmos demo disc, and go to the test signals, go in there, match it to the system you're using, and make sure all of the speakers are there. Make sure you actually have everything connected correctly as you go around the room. In the case of the Dolby one, they chose an order of speaker positions, which is whatever, but it goes left, right, center, and then subwoofer, and then this, and then that, whatever. The speakers are all there. I like going around in a big circle.
Yeah, in an order. Yeah, right. Yeah.
Whatever. So do the roll call. Now by now you've probably found some speakers that are either missing, tweeters not working, woofers not working, or channels are inverted. So like you see on the screen that it says this should be a side left speaker and it's playing out of the back right. Well, you go back over there and you got to figure out where that got screwed up. So once you assume that everybody's there and connected, we're going to check that the voltages at the speaker terminals are right. And I know that sounds like, what, huh? You're gonna take a voltmeter and you're gonna play a test signal that's 1 kilohertz at reference level that we actually have available on a calibration DVD I produced years ago with Goldline. And the test setup looks like this. You put the disc in the player, you run it through the controller at the reference level, which we'll talk about a little later, and you verify that all of the speakers at 1 kilohertz have about the same voltage at the speaker terminal. So they're all going to be playing 1 kilohertz together, beep, like really annoying to listen to. You definitely, I forgot to put, by the way, the list of tools you should have is a pair of earplugs, because the entire day you're going to be listening to some pretty loud signals, and you don't
actual protection. Yeah. I've found some that I love going to concerts. They attenuate the sound without really changing it too much. I mean, much better than the little foam expanding ones. And coincidentally, they're the same manufacturer as your headphones. They're Edamonic. I love them. I've had them for years. I recommend them to everybody. I bought them for Christmas gifts for people because I know they go to concerts and don't wear earplugs. They're a great brand and a really good price too. They're like 20 bucks, 25 bucks on Amazon, something like that.
They're not expensive. And so there's a whole bunch of different ones. What's kind of cool about the Etymotics is they have a little thing that sticks out.
Yeah, right.
Is that cool? Well, it makes it easy to find them, but also people who are seeing you see that there's something in your ear and they know that, oh, it looks like they have an earplug on. I have other really good earphones that are flat.
Yeah.
And they block the sound, and people come up to you and they're like
screaming at you. Yeah.
And they're like, and you can't hear them. It's like, I'm sorry, I've got a potato in my ear.
Yeah.
All right, so we're going to check that the voltage at all of the speaker terminals is the same. Normally, it should be somewhere around 2.6 volts RMS. Long reason why. If it's 4 volts, if it's 1 volt, whatever it is, it should be all of the same coming out of all of the speakers, given a same input. And if one of them is wrong, got to go figure out what happened. Something's wrong somewhere. Don't compensate for that wrong by turning up a level somewhere else, because you may be overloading something, you may be missing something. The most common reason for something to be wrong at this point is if you're running balanced line audio, one of the legs of the balanced line is missing, either the plus or minus, and you'll see the signal be half that voltage. Here's the tools of what's called a TK51 test disc and a voltmeter, any decent RMS voltmeter. This happens to be something Radio Shack made and sold many years ago. I think they still have them. Yeah. But you can actually buy from, our friends at Amazon with an unknown source somewhere for $7 or $8 a very good, usually yellow or orange kind of cheap plastic thing. That's a true RMS voltmeter that's good up to 10 kilohertz. It's all you need. If you want to show off and have a really nice tool in your hand, Fluke makes about the best of these things, and not all of them are true RMS and wide bandwidth, by the way. You definitely want one that's specified to be good to at least 10 kilohertz, if not 20.
There was a question real quick, Anthony, from Samir on the previous page. He's asking if the measurement that you take with the meter at the speaker terminal, does the impedance of the speaker make any difference at all here, or should we still be the same voltage all the way around no matter what?
If it does, you got a real problem going on. So this is done with the speaker terminal hooked up. Right. And this is at the speaker terminal, which if it's a system where it's all hidden and you can't get there because there's fabric, you can't do that. I do recommend, if you're designing the system and you're going to be calibrating, that you actually run little probe wires down behind the speaker down to a little hidden location under each speaker, so you can go measure it.
A little trapdoor or something.
Or just a little pair of test points that you can see at the bottom of the fabric that nobody else can see, but you know.
So you can just touch, with your probes. Yeah, that makes sense. Cool.
If you have a proper power amplifier with an output impedance of 0.01 ohms for a decent amplifier, and a speaker with an impedance of 4 ohms, it doesn't matter where you hook it up or not. There should be very little change. If there is a change, you've got a problem with either the amplifier or the speaker wire that's going to the amplifier is way too thin and way too long and has become resistive. So somewhere you could actually try that and then disconnect the speaker and reconnect the speaker. And if you see a change in that, something's wrong. I'm coming up to that in about 5 or 6 slides. I think there's that topic is brought up, and that's a very good, it's a good question, and it should not change.
Good.
All right. Next thing we're going to do, by the way, I'm pretty sure at this point that nobody who's watching ever does this. And why do I do it? I do it because in the beginning, I didn't used to do it, and things went wrong. And then, 7 hours into the calibration, I finally realized, oh my goodness, there's a connection error, or there's a problem with this preamp about something. And so I've been calibrating, and one channel's not been working correctly. So to stop, rewind, start over.
And I mean, maybe a drywall screw went through a speaker wire somewhere. You have no idea. I like this. And Anthony, admittedly, I've never done this before, but I'm going to have to add it to my repertoire, to my workflow.
Right. So drywall screw right here. Let's talk about this. So if there's a drywall screw right here that went into the insulator and it's not shorting out the wire, you have signal. At 100 millivolts, it'll pass. As you go up in voltage, there's a point at which the signal may short out. It's going to ionize, do what's called a Schottky diode effect. And at some point, you're going to see that one channel, instead of putting out, actually Schottky diode starts a little bit higher in voltage. It's really at 3 or 4 volts, but you'll see that speaker, for one, sounds weird. Instead of giving you a nice clean boop, it's going to sound like yes, I do sound effects. And then you're going to see it in your voltmeter for some reason. Foley. All right. So next thing we're going to do is along the same lines, which is we're going to check the frequency response at the speaker terminals. So we're going to do that with an analyzer. The test setup is similar. Easiest thing to do is to use one of these two test discs over here, either the 5.1 audio toolkit or the Atmos calibration or the Atmos demo disc, and you're going to go through each channel at a time and go to that speaker. And the setup is similar, except that the device you're measuring with is no longer a voltmeter, it's actually a spectrum analyzer. So in this setup, you're running pink noise at, let's say we're testing the center channel. Pink noise, you go over to chatter, I forget, sorry. So 1, 2, 3, it's number 4 on the Atmos disc. Hey, Jason, I'm noticing that my video is kind of getting pixelated once in a while. So for now, I'm going to go ahead and mute my my camera.
Okay, yeah.
Are you seeing that also on your side?
It did kind of pixelate there for a second, and we lost your voice for like a second. But if you want to be safe, yeah, go ahead. That's fine.
Okay, I'll mute that for a second, and then maybe I'll come back. I'll monitor what you're looking like, and if you're all good, I'll do that. Okay, so so the 1 second here. I'll give you an opportunity to monitor that thing. Okay, so same thing, disc is put in a player, and this is why you need a Blu-ray player. By the way, if the client's really, really resisting having a Blu-ray player because they're being a cheapskate and they don't want to spend whatever it is, $200 or $300 on a player, bring your own.
Bring one, yeah.
I usually carry a little basic, cheapo, simple one in my toolkit also. A really simple Blu-ray player is very light. So that goes through the decoder, through the power amp, through the EQs and everything. And at this point, you're going to put the measurement of a spectrum analyzer. So I'm going to talk a little bit later about what is a spectrum analyzer. I'll just say this is where you're going to measure. In the olden days, it would have been an actual box, an actual device that somebody makes. In today's day, it's an actual piece of software running on your laptop with a USB interface. But you're going to take the signal at those speaker terminals and you're going to connect them into your USB interface, probably through the mic input. It's fine. This doesn't have to be done at a very high voltage. And you're going to check and see that you've got a decent frequency response over there. So what it should look like ultimately, and it's fine to use pink noise in real-time analysis mode. And what you should see, because you've set the base management, is something that looks like this curve. I know this is a very grossly simplified one, but let's say you chose 80 hertz for the subwoofer crossover. Above that, you should see a straight, perfectly even line all the way up to 20 kilohertz, and below that, you should see the fall-off slope of the crossover. And what this does is verifies many, many, many different things. For one, it verifies that you actually did configure the crossover correctly. We've all been in front of menus where you pick something, you select it, and you don't realize that in order for it to really be selected, you had to hit the save button twice, walk backwards while speaking in Swahili and writing it down in Cyrillic alphabet somewhere. And I kid you not, sometimes it's that arcane to get these decoders to do what you want them to do. So here you're verifying not only that you've selected the right crossover for the subwoofer, and if you guys are going subwoofer crossover, why? Go look at the session on subwoofers. How many, Jason, what's it called again?
Subwoofers, is one enough? And the answer that I have been preaching for years and you verified for me, thank you so much, was 4.
Was 4.
Yeah,
either way,
enough.
Right, you need to have a subwoofer, and 4 smaller ones laid out correctly in the room is the right thing. So what you're going to check over here is, so what could go wrong? One thing that could go wrong is somewhere in the menu of the surround decoder, they had a mode called dialogue enhance, and you didn't see it. And suddenly there's a bump in the mid frequencies over here. There's a thing here that's pushing up 2 or 3 kilohertz. Or you may have had a high frequency equalization something or other, and there's a droop. Or actually, the olden days of bass and treble controls on the front panel of surround decoders is gone. And some of them still have bass and treble controls, but they're down inside a menu. You have to go find them. And unbeknownst to you, before you got there, the client boosted the treble all the way up and the bass all the way up, because that sounded more better. Right. That's what people always do in the beginning. And so you're going to start to calibrate a whole system. And unbeknownst to you, the bass is up 6 dB and the treble is up 6 dB. Well, you're going to find this out, and you're going to find it out right here. You're going to see that instead of having a flat frequency response in the speaker at the speaker terminals, it's wrong. The other thing that could happen, and I'm about to talk about that, is that the speaker wire is too thin and too long. So some of you are asked sort of about this. If you have 100 feet of 16 gauge wire between your surround decoder and a speaker that has a stated impedance of 4 ohms, you're going to see an error in the frequency response over here. And that error is going to follow the impedance curve of the speaker. You will see it in this measurement. So what do? Well, you could change the wire. But let's say you're there for just 2 days and you can't change the speaker wire. You're not allowed to do that. Well, at least you can start off with the equalization process here and dial in an EQ to correct for that electrical response. It's not fixing everything because you still have too much resistance between the amplifier and the speaker, so the control of the speaker is not going to be very good. But at least you're starting off with something that's got the right response. And does this happen often? Yes, it happens often.
Wow.
So I think the worst case I ever saw of this was system. We had designed the speaker wire runs were about 20 feet, perfectly fine for 14 gauge wire. And one of the speakers, I think the center, had a really horrible frequency response at the speaker terminals. I was like, what's going on? You know, plus and minus 3 dB electrically. What's going on? Start to ask a lot of questions, more questions. And as it turns out, about an hour investigation, because that's kind of how I am. I don't let go until I actually have the right answer. Turns out that the wire inside the walls was cut by the electrician by mistake, and they spliced it. But when they spliced it, they didn't really know how long they had to do. So they left actually a big piece of wire spooled up in the back. So it's like, yeah, whatever. It's all fine. And so instead of having 25 feet between the amplifier and the speaker, there was actually 250 feet of speaker wire.
That'll do it.
And so, first of all, shame on you for cutting this wire by mistake and not telling the integrator, because that's BS, man. That's bullshit. And then, you know, shame on you for leaving all of that wire coiled up there because you just didn't know what was going on. And then it would have been shame on me for not having found it. Yeah,
and that's such an easy. I mean, especially that example, that's such an easy fix if it's brought up and somebody knows about it. But if they just try to band-aid it like that, and look what happened. It burned you in the end.
Yeah, well, in this case, it actually took climbing up into the attic and crawling around to go find the thing, you know.
Oh, man.
You know, on a hot, sweaty day in fiberglass.
Of course.
My favorite thing, to like find that thing, fix the splice, and there you go. So, all right. So I talked about analyzers. Let's pause 1 second. So in the olden days, an analyzer was an actual piece of hardware you would bring with you, made by somebody. There's a bunch of different people that made good ones. Today, I advocate that to simplify your life and to do something good, you use your laptop as an analyzer, not your cell phone, not an iPad, but your laptop. And you download this amazing program called Room EQ Wizard. Okay? It's a free download. However, when you first download it, it asks that you donate something to the people who designed it. And please, please, please donate them some money. This is a piece of software that should really sell for $3,000, given how powerful it is.
Yeah,
it really is. It's an amazing tool. And the people who designed it are altruistic, and they go, well, you know, I want to do something good for the world. I want, you know, I want people to, you know, learn how to do better audio analysis and stuff like that. And really, the sophistication of this thing is unbelievable. So my pitch is, you know, give them $50, give them $100, give them your whole inheritance, give them all your fortune, whatever it is, just give them something. Now, that piece of software, you know, you load it on your laptop, and if you want, you could actually plug a basic USB microphone into your laptop, available from many different sources, but you know, usually Parts Express has 2 different models. I like the UMM6 better, and that's your input. That's your actual acoustical measurement device, and you can take the headphone output and use that as your output source to all of your devices. It's okay to do that. Most laptops have a good enough headphone output. It's going to work, and those USB mics are pretty good. If you want to step up to the next level, you get yourself a USB interface. Shure makes this really simple little box, little thing that you plug on the back of a a microphone called the X2U. Works fine. It's pretty low noise. Actually, I'm speaking to you through one of those.
Oh, nice.
I have that thing plugged to the back of my microphone. Here, I'll switch over. All right, you should be seeing me again.
Yep, I got you back.
So this is actually what I'm speaking to you through. So microphone, Shure SM58 Classic. Can you still hear me?
Oh yeah.
Plugged into this little device that's a USB interface, and the output of that goes to my laptop. I use that for analysis when I'm in a real hurry, or if I don't want to carry the bigger thing I have, which is a USB pre. This thing works wonderful, wonderfully, to speak in proper English. So I'm going to leave my camera back on here, see if we can do things without being Mr. Pixel Head here. So the idea of using an outside, there you go.
There it goes. As soon as you fired it back up, it flaked out again. That's okay.
Okay.
There we go.
I'm gone. All right. Can you hear me now?
Yep, sounds good.
Hey, I forgot to bring it here actually, but what I usually use is a bigger interface, which is a brick made out of metal. It weighs a fair amount. It's got two XLR inputs, two XLR outputs, digital audio output, analog output, all kinds of different things. It's called a USB Pre 2, and that's what's shown here. Actually, let me fix that because the old version don't work so good no more, like they say. That is the model of the device. It is about $600 or $700. If you're serious about what you're doing, you should have one of these interfaces. So, oh no, didn't mean to do that.
Oh, you went back to the beginning. Oh, that's okay.
Let's see. Where were we?
Right about there. Oh, there you go.
There. F5, Shift F5.
Boom, okay. There you go.
So the idea is to have a device that's plugged through USB into your laptop that has the microphone's input on it, has feeds to all your source devices. It also has balanced inputs, line level inputs, and with that you can do everything you need to do. And so ultimately you've got a piece of software that's cost you $50 or $100. You've got a decent test microphone that's cost you between $7 and $150, depending on which one you're using, and you got an interface that's cost you between $90 and $600. Yeah. You've got a really powerful toolkit that used to be way more expensive, way more complicated not so long ago. All right, and so this is actually just a measurement. I don't know of whatever. This is a study, no EQ, blah 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 blah. This is a measurement done on Room EQ Wizard. And it's very, very powerful. If we actually do a session together, I'll spend a whole bunch of time on how to use this thing.
And I'll second that too, guys. In calibration, we've tried and used different software programs over the years, and the more that I've been kind of poking around with REW myself, I mean, it does kind of seem like I agree with Anthony. I think it should be way more. I think it should not be free. I think it should be way more expensive. The people developing this have been working on it for like a decade or longer, and it's very, very good. So I agree with Anthony. Donate to those guys. They do an awesome job.
Right. So it's interesting. I was just, as you were speaking here, I was thinking that if I wanted to go into the steps, phases, processes, and analysis I do with REW, that would probably be 2 hours.
Yeah, and
just a tour of that piece of software and what you do with it.
I think it would be great. I know I would personally benefit from it. I've tried poking around on YouTube and seeing some of the tutorials on REW, and there's 9 million different people doing it 9 million different ways. Some of the videos are old with older versions of the software. Some, it's kind of all over the place. So I think that would be an awesome session, is if we sat down and went through REW together. If you guys agree, please let me know, because we can certainly set that up. Dan already says that he's in, so yeah, I'm sure we have a lot of people.
He's doing it. He's doing it.
Yeah.
So one of the very cool things about REW is this I don't know, I could sit here for a whole day, but you see this thing called EQ? You see this little button right here? I don't know if that's coming through in resolution on the webinar, but
you can see it. Yeah, you can see it. I
one
can't.
of the things you can do is you can do a measurement. You can go, okay, so I got this measurement, 1. 2, I've got this target curve I'm trying to get to, and I'm going to explain this concept of target curve a little later. And then 3, I've got this particular EQ model, and there's like a long list of different equalizers you can tell it you may be using. And then you say, well, tell me what I should do. So we're going to get to later about, how you adjust the bands of equalization, or you can actually ask REW, what do you think is the best combination using the least number of bands to get to smooth this thing out or get it to the target curve? And sometimes the results are surprising. And it's one of those that, like you're playing chess and you're seeing all the move in front of you and you start moving all your pawns and somebody that's a whole lot better chess player than I would be, or you would maybe, can see, you know what, if you move these 2 pieces over here, you're going to checkmate that person. Well, I didn't even see that. And that is what the optimization module in Room EQ Wizard can do, is to just give you the numbers. But wait, there's more. If it's one of the equalizers you're using that actually talks to Room EQ Wizard, you can actually push the coefficients right into the EQ. So you don't even have to like dirty your hands trying to like build bands. You just go, boom, do this. So this is as close as a properly done computer assisted EQ that sometimes people call auto EQ as I can think that works. So anyway, enough on that. Let's keep moving on. Now, next system verification we're going to do is the load impedance. And at this point, you're like, dude, you're an hour and 15 minutes into this and you haven't started calibrating. You're right. You're totally right. There's a lot of things you got to verify before you can calibrate. Otherwise, it does not work.
It's all in the prep work. It's just like making a meal or calibrating video or, painting a car. It's all in the prep work.
Right, exactly. If you don't prep it correctly, the paint looks like orange peel and it's just horrible. So what are we doing here? A loudspeaker is defined as an 8-ohm speaker, for example, but it really, what they're not telling you is that the impedance is going up and down with frequency. And you want to check that the manufacturer didn't lie to you or is not causing problems to your amplifier. So you're going to measure the actual AC impedance using an impedance meter. You're going to check at various frequencies, and you're going to avoid any speaker that's below 3 ohms. But moreover, I forgot to write it in here. If you have 3 identical speakers across the front, you want to make sure that their impedances are similar. And if you have 6 surround speakers for the sides and backs, you want to make sure that as you're measuring them, they all look about the same. Whatever their numbers are, you want to make sure they all look the same. Now, where do you get an impedance meter? Goldline made this thing called a ZM1, which is made for both 70-volt systems and low impedance systems. I was actually thinking yesterday as I was rewriting this, I forgot to check and see if they still have this available. I'm sure it's available on the used market. It's a great little box.
I'll look while you're talking.
You can also use Room EQ Wizard with a special interface. You can look on YouTube for how to do with that. There's a bunch of ways to do it, but this, I want to be clear, this is not a regular ohm meter. A regular ohm meter that's available in a $10 multimeter is only checking the resistance at DC.
Right.
What you're trying to find out is what this thing is doing at 100 hertz, 300 hertz, a kilohertz, 10 kilohertz, a range of frequencies, and you have to have essentially think of it as an AC ohm meter. Okay.
And there's lots of them out there too, by the way. They still looks like they're still sold many places.
Great.
New in box.
Great little box. So, all right. Next thing we're gonna, we're not done yet. This goes back to, I think it was Samir was asking about this. Is okay. We're gonna check. Again, I'm assuming you're going in cold into this system. You've been asked to calibrate it. You don't know very much about what's there, or maybe you do know what was there, but you're checking that nothing got screwed up. We're going to check the speaker wire loop resistance. So what we're doing here is, this is with a regular ohm meter, standard multimeter. We're going to measure the loop resistance of the wire going zip over the speaker and back, and you're going to put a little shorting plug at the speaker. What we just want to measure is what's the resistance between here and there.
Okay.
Warning, we're looking for anything we want to make sure that it's not over 0.2 ohms, and that's because given a typical speaker that may go down to 3 or 3.5 ohms, we don't want to add an extra 0.2 ohms to that crossover, or else we're going to have some problems. I know that seems 0.2 ohms versus 3 seems like nothing, but that's where you start to hear the errors, because it's going to introduce a 1 dB frequency response error at the terminals even before you get to the acoustic of the speaker. So the cheaper meters are not going to display much below 0.5 ohms.
Mm-hmm.
So you want to have a meter that actually has good resolution down to 0.1 ohm, so you can actually see this. This is a place where spending a little more money is going to help. All right, next thing we're going to verify is hum. So you have this rack of equipment with cable TV inputs, satellite TV inputs,
Mm-hmm.
HDMI, this power here, power amps plugged in over there, a projector somewhere else plugged into different power. The chance of having hum in the system is really, really high.
Sure.
Hum often being introduced by a hum loop, by inconsistent power between all the different devices. You gotta check for it. So you're gonna go up close to the speaker, listen to the sound coming of it, make sure it's dead quiet, and the only thing you hear is a little hiss, which you should hear. There's amplifiers and surround processors put out a little hiss. That should be coming out of the tweeters, but you don't want to hear.
Mm-hmm.
If you're not sure, you should measure it with a spectrum analyzer, and there, again, in the olden days, that took a pretty complicated piece of gear. Today, with Room EQ Wizard, you can actually just plug the speaker voltage into the XLR input of your analyzer, of your USB converter, and measure that. It is a good idea for this to have your laptop floated, so not plugged into power, so it's completely independent of that. And look at the spectrum of that signal. And as you go around trying to fix it, you can, if you took a picture of that spectrum, you can see as you're changing different wire connections, different ground conditions and stuff, you can actually see whether you've improved things or not. Otherwise, you're always coming back and listening and going, hey, is that any better? I'm not really sure.
Right.
I think you got better. What do you think? I don't know. Well, maybe, yeah, why don't you try it again? No, if you can actually measure it, you can see, hey, look at that. The hum went down by 10 dB. Let's keep going here. Okay. Now, you showed up on site. There's hum in the system. What do? You pack up, get back on a plane, and go home? No, you try to fix it. One of the fixes is to make sure that either you or the installer, whoever's in charge of the system, has a bunch of isolation transformers available. So the choice transformer is the really good products made by Jensen. That's like they're expensive. You know, if there's 12 channels, you need 12 transformers, and you may put them between the surround decoder and the EQ, or the EQ and the amp. Somewhere you need to break a hum loop. But I've actually found that there's other little cool gizmos out there that do a pretty good job of being a decent transformer, including Mux Labs. Mm-hmm. So Mux Labs, for, I forget the price of what they are, but they make a 2-channel. It's really not made to be an isolation transformer, but it's a box that has an unbalanced input to balanced out that you connect through Cat5. It's a way to extend line level signals through a Cat5 signal. And the hi-fi version of that is a good isolation transformer. So you can put, you sort of hack that thing up, but you can put it between your between your surround decoder and your amplifiers, or between EQ and amplifier, wherever you need to do the isolation. That works okay.
Can we just touch on one thing? And this is excellent to ask you, since you're an engineer, but and I know they're bad, but I just want everybody to understand why and make sure they know that they're bad. What about those just little ground lift adapters for, here's an example. I had a townhouse at one point. In that system, I was running 2 subs. One of them was humming like crazy. I was renting the townhouse. I wasn't going to tear up the wiring and do all that kind of stuff. So I just grabbed one of those little adapters, and it turns out that maybe for a temporary fix, but not a long-term fix. Can we talk about those really quick?
So you're talking about what's called a cheater, like for the 3-prong.
Yep.
You should absolutely have that in your toolkit.
Sure.
Because one of the elements of debug, again, I could spend 2 hours just talking about hum debug. Why? Because I spent 16 hours trying to debug a simple
trying to figure it out. Yeah.
Actually, one of my first big jobs was actually rebuilding a radio station, and did everything was working right, put it all online, there's hum all over the system. And it was literally 2 weeks of chasing everything down. There's tons and tons of connections. But so the cheater is a way to start debugging. So you know, in your case, your subwoofer was a place where you actually found the hum loop.
Right.
And the cheater has lifted that, except that it's made that subwoofer float in terms of its reference to ground, and it is now dangerous. So as a professional, you should never do that.
Right.
You should never float a product that's got a pin that's supposed to be grounded. If a product has double isolation and it doesn't have a third pin, it's floating, right? So don't worry about it. But if it actually has a ground lug, it's got to be grounded. The cheater just helps you figure out where you're starting.
Right.
So now that you found out that lifting the ground on that subwoofer helps, now you got to go figure out where it is that the actual ground connection is bad. And it may just be that where you're plugging that subwoofer, either the neutral or the ground is in a completely different voltage and everything else in the system. And the solution there is to go, if you're serious about it, is go fix it. So you know, now you got to go play electrician and go see what's going on in the panel. It's made that, that neutral be wrong, or run a long extension cord to that subwoofer from what's feeding the rest of your system, which could be ugly, but maybe that's what you got to do.
So good tool for troubleshooting, but not something you should leave in the system.
Absolutely not.
Right.
Absolutely not. All right. We're going to check another thing. So, you know, here we are, an hour and 20 minutes into this thing, and I still haven't talked about any of what you guys were thinking you're going to be hearing about. And that's all because you're going to thank me for bringing all of this stuff up, because really what you want to hear about is actually pretty damn simple and would be a 10-minute conversation. And you'll see I'm just going to rush through it in the end because that's the simple stuff. Okay, next thing is to check if your power amplifiers are oscillating. You're like, what are you talking about? Well, this is particularly true for traditional Class AB amplifiers, less and less in modern products that have switching amplifiers. But realize that the amplifier is not driving a resistor. It's driving something that could be modeled as a combination of resistors, inductors, and capacitors. And those can be very difficult load to drive. And the amplifier, when they're looking at that, could be just oscillating, as in the speaker is acting as what's called a resonator circuit, a tank circuit, or an oscillator, and the amplifier working with that particular wire, with that particular speaker, is sitting there oscillating at 1 megahertz or half a megahertz or 2 megahertz, because that's just the loop that's created. And you can't hear that. Your tweeters are not playing it because they're fully inductive at that point, so they're not passing it. But meanwhile, the amplifier is sitting there putting out half a volt, a quarter volt, or 1 volt at 1 megahertz. Well, that amp's going to sound like guano, bad. You could argue that in some cases that power could be dissipated in the crossover and warming it up. It all depends on a lot of factors, but you got to detect that. So the way you detect that is you get an oscilloscope and you measure at the power amplifier with the speaker connected. Actually, I don't know that I have a diagram of that, so I'm going to go back to this. And sorry. So that would be, you would measure that right here under these conditions. This is interesting. You actually would want the system to be unmuted. So there's a few surround decoders out there that if they don't see any input, they go into full mute mode, including the power amps, and you're not going to see the oscillation. So you actually want to play a disc. Well, I'm getting very emotional about this. You want to play a disc that's playing audio black, the same thing as video black. And on the 5.1 audio toolkit, there's a whole section that for 2 minutes, I think, it's playing a Dolby Digital signal, but it's got no signal on it. It's just zero. And you need that to make sure the whole system is unmuted, and you're going to measure here. And you're looking to see if the power amplifier is oscillating. So let's go forward over here.
And that's with the speaker connected, right?
With the speaker connected. You want to see if that whole system is causing any problems. So you measure with an oscilloscope. And what's an oscilloscope? Well, in the olden days, it was this enormous box, the size of a suitcase you had to carry around with you. And I used to carry one on airplanes. I didn't entrust it to the airline guys. I carried it with me, put it through the X-ray machine. They would look at it and go, "What's this?" I go, "An oscilloscope." They go, "Oh, okay, thanks." And it's like, "What do you mean, thanks? You should ask a few more questions. It looks like a doomsday machine." No, it's. I actually had one TSA guy goes, "Yeah, it's an oscilloscope. It looks like a Tektronix." Yeah.
You're like, "Whoa, hey, you
know." Crazy. But good news for y'all road warriors out there is there are digital oscilloscopes that can either be an interface device for a laptop, or for relatively little money, you can buy handheld scopes. Like $200 or $300 will buy you something that looks like this, that's good for up to 25 megahertz, and you can actually measure what's coming off the amplifier. All right. Next thing, we're not done yet. You got all these speakers in the room. Are they all working correctly?
Yes.
So I always check that after the speaker's been made, shipped by our friends at the United Parcel Service, who are excellent at throwing things around, and then installed and put in place, and these speakers have been in environments with a lot of dust and a lot of metal and a lot of stuff. I check to see that there's no scrapes, rubs, or buzzes, or cabinets that are broken. And what I do is, one channel at a time, I run a sweep through each one of the speakers. It goes all the way up. Do it slowly, not that fast. You want to check and see. And I'm just listening for the speaker sounding clean and not having any buzzes or crunches anywhere.
Nothing obvious.
Nothing obvious. Low distortion and low buzzing. And sometimes something will buzz at low level and not at high level, and sometimes vice versa. So you want to try at 2 or 3 levels.
Anthony, you know what these little exercises remind me of? It's like when you go to the doctor for some big problem, but first they still tap your knees, they still check your balance, they still, because if none of that stuff is right, then the stuff that you're there for is you're not gonna get the right diagnosis.
Right. These are all things that I call the vital signs. So
yeah,
let's say you don't do this, and you go through the whole process, and you do your EQ. You spend 2 days tuning the system, only to find out that the center speaker has a cabinet rattle at 200 hertz because it was sent over and dropped by our friends in the shipping business.
Like trying to calibrate a broken TV. I mean, it's the same thing, right?
Right. And so start over. Just wasted a bunch of everybody's time. So, and I'm not talking in theory. I'm talking from experience. Okay. I do want to say that all of these things I've done to verify stuff is just what you're benefiting from here is I didn't used to do this until I got into trouble. Spent 2 days trying to tune a system, only to find out that there's a problem. And then, just like the who's the administration that checks for error? I'm forgetting the name. Every time a plane crashes, there's always an investigation done. The investigation tries to conclude whether it could have been avoided. Right. And if it could have been avoided, was it because those 737 Maxes needed to be built better, or something else, right? And that is how aviation has become extremely, extremely safe. And it's the same thing over here. Every time I run into a crash, not in my airplane, I record it and I figure what it is, and then I check for it so that I don't get caught next time. Don't run out of gas.
So all these things, guys, this isn't just like things that he's making up. It's things that he's learned over years and years and years of experience. So I would definitely be adding these things to the checklist.
Right. So this is part of why the checklist is 40 pages long, because every one of these things. So when we get to speaker rub and buzz, that takes an entire page. It's like there's an entire page of Word document in which each speaker has its own little place. I write what I tested. If there's any problem, I write what it is. The cabinet rattled at 250 hertz. Now, why did it rattle? Well, was it just bad manufacturing? If you're lucky enough to have 3 of the same cabinet, you can check that all 3 of them are rattling. And that's a design error. Or if only one of them is rattling or buzzing around, that's either a particular manufacturing error or the thing got damaged during transport or installation. Now, don't confuse rattles with buzzing or rubbing of a cabinet. A rattle, what I call a rattle, because we're going to get to that in a second, is something else in the room is rattling. It could be a light fixture, it could be a door, it could be a window. So you kind of have to isolate those things, figure out which ones they are. Doing that verification in the olden days, it would be with an analog single tone generator, and you can still do that. You can carry a little box around with you that you plug into each input of the amplifier one at a time and run a sweep. Or Room EQ Wizard has single tone generator in it that you can sweep slowly. It's really cool. You actually use the spectrum analyzer screen and you slowly sweep up that thing, and then you can stop at whatever frequency you may hear something, and either use your USB interface or your headphone output to feed that particular channel. Now on the TK51, on the audio toolkit, there are some sine sweeps, so you can just play those slowly and listen to them. The benefit is you don't have to set up a piece of test equipment. The disadvantage is you can't stop. If you hear something as you're going up, suddenly there's a cabinet rattle, you'll hear it come and go, but you can't stop right there. All right,
guys, real quick, I'm gonna put that TK51 disc into the chat because it seems like it's come up a few times now. There might be some folks who are interested in it. I found it online. I'll just send everybody a link.
Yeah, there's a bunch of people who still sell it. It's
out there.
It's not a lot of money, and it's totally worth it. So, and you know, yes, I did produce it, design it, and I was hoping that since then somebody else would come up with a version for Atmos. There is none that exists. I've been made aware, by the way, that you can download an application for Apple TV to do a bunch of tests through an Apple TV. I have not had time to check that yet. I will do it soon. It's about $120. Again, not a big deal for good quality work.
Sure.
If any of you guys that are listening have tried that, please do let me know. I'd love to get your comments. Okay, we're going to check one more thing. Yes, we're not done with the verification. We're going to check the speaker frequency response near the speaker. So what we're going to do is we're going to take our test microphone, plug it into our Room EQ Wizard. We're going to measure each speaker at about 3 feet from the speaker in the near field. And what we're looking for is any obvious errors, something where, hey, that speaker has no mid-range. There's like a giant hole. If it's a 3-way speaker, there's a giant hole between 500 hertz and 2 kilohertz. Well, you may as well find out now before you spend a whole bunch of time calibrating a room that then you have to stop and start all over again. So you're going to use your mic and your analyzer, and you can do that with either the impulse response function in Room EQ Wizard or the pink noise or the pseudo-random pink noise with a real-time analyzer that's an FFT analyzer. However you do it, just get a sense for what the near field response is. So what I'm calling near field is you're close enough to the speaker that the room doesn't influence it too much, and you should expect a reasonably smooth response from all decent speakers when you're just 3 feet away from it. Okay, we're going to verify one more thing. Yes, we're still verifying, and that's the acoustic polarity. So
sure.
If the speaker is built correctly and you've wired it correctly, a positive signal coming out of your signal generator or out of the test disc or out of the program material should come out as a positive acoustic pressure, which means that the woofer or the mid-range of the tweeter is pushing air out into the room, and when you measure it, you're going to see that. So you're going to verify the wiring, of course, make sure that all the pluses and minuses are correct, but you're also going to verify the polarity, and there's little polarity testers you can use in which their theory of operation is simply that they put out a signal that's at DC 0, and there's a positive going pulse only coming out of that. You feed that into the power amp, and a little box with a green and red light is looking for whether the net pressure is pushing the microphone in or pulling it out.
Right.
So Goldline makes this thing called the APT2. There's also, oh, and by the way, that is a 2-piece system. There's a generator and an analyzer.
Sure.
In the 5.1 audio toolkit, there is a test sequence that has all of the channels playing the special little pop all at the same time into your system. There's another polarity tester, I thought it was here, called a Cricket. It's another one. There's a few different ways to do that. I do want to mention, though, that on some speakers, like 3-way speakers, the woofer may be positive when the mid-range is negative and the tweeter is negative, and that's intentional. Or a woofer could be positive and a tweeter negative, that's intentional. You just need to know what was the intentional response. And so if you start measuring and you see that the mid-range is out, don't immediately stop and think this thing is broken. Go measure other speakers in the room that have the same speaker. So hopefully at least you have a pair of speakers that are the same, the left and rights, or whatever, as you go around the room. If you're not sure, if you're wondering, hey, should the speaker really be polarized that way, and you don't know what it is, where do you go? What do you do? You pick up the phone and you call
the manufacturer.
Call the manufacturer. And of course, the person who answers the phone won't know. You ask to talk to engineering, and you go, hey, I'm out calibrating a system with your fine speaker over here, and I'm wondering what the intended polarity of the woofer, mid-range, and tweeter is supposed to be on this thing. So when the engineer is done, like picking up their jaw off the floor, going, I can't believe somebody's asked.
Someone actually wanted to know this, yeah.
And you say, well, I'm checking the polarity of this whole thing, just making sure everything's working right. They're going to go, oh, hold on, let me go back through my records. Oh, yeah. On that speaker, we have this kind of crossover. Yep, you're correct. The mid-range should be negative. You're done. You did your work for a day. What happens if that speaker wasn't built right? And let's say you have 3 of the same speakers across the front, 3 three-way speakers, and one of them has a mid-range built incorrectly because it was wired incorrectly because the guy who was soldering that or the gal who was soldering it at 5 o'clock on Friday just wanted to go, go home, and they wired it correctly. You're the last line of defense to fix that. So if it turns out it's wrong, and if you have permission, you can actually pull that mid-range driver out and correct the error.
And I did find that Cricket speaker polarity tester, so I sent a link to it in the chat box.
Great, thank you. All right. Next thing we're going to verify is, hey, does this system actually have enough headroom to play my movie correctly? So I know I'm still verifying. That's what it is.
That's part of it.
Takes a day. So a few ways you can do that. My favorite way is to just play pink noise from 100 hertz to 6 kilohertz, and actually with Room EQ Wizard you can actually set the bandwidth of the signal you want. Very, cool. Very cool. And you crank it up until you sounds like the speaker don't want to do it no more, and you measure the value of that. You should get at least 95 dB of signal of sound pressure from any of the speakers in there for a mid-quality system, and at least 100 dB for high-end systems. That's the average level with not very difficult signal. It's only going down to 100 hertz up to 6 kilohertz. Don't do this for too long because you may actually start blowing up speakers. Right. Or you could argue that, hey, if it's blowing up, it wasn't fitting of this client. Yeah. But you should do this. You should know how loud the system can play before you assume, hey, my client's going to love this thing. Same thing with a subwoofer, but you're going to use pink noise from 30 hertz to 80 hertz. You're going to turn it up until you hear some kind of distress or some limiting, and you're going to measure it with a good SPL meter and look for at least 105 dB for mid-quality systems and at least 110 dB for high-end systems.
Anthony, on these measurements, is it in the listening position or right up on the speaker, or what distance?
That's at the seating position.
Great.
And you may want to move the meter around to make sure that any standing waves in the room aren't interfering with your results. So look at an average, but know that way at the beginning when I talked about the reference room, that room can play 115 dB in the bass any day, all day long. Ideally, you want to play 115. You want your subwoofers to be able to play 115 decibels. It's hard to get there. If you play 110 before it limits out, you're pretty close. Okay, so we're done checking the system. Now we're going to verify that the room doesn't suck. So first thing is we're going to look for flutter echoes. That's a sometimes known, well, there's a bunch of different words for that, but it's slap echo, a zingy echo. But you clap your hand, you go around the room clapping your hands, and you listen for echoes. Does that mean that the room is going to suck? Well, maybe yeah, maybe no. What really matters is for you sitting at the seat position, you want to listen to what somebody walking around the room clapping their hands can hear. There's people who disagree on the audibility of this, and Floyd Toole and I have had long arguments about it's audible or not audible. I've run tests in recording studios where there's a slap echo behind the mixer. Yeah. Not at the mix position, but behind the mixer. And I've had the mixer listen to his program material and put up an absorber panel to get rid of the slap echo. He goes, oh, what'd you do? The sound changed. So again, there's a slap echo away from where the listener can hear it, or you have to stand behind the mixer 2 or 3 feet and clap your hands before you hear it, and they hear it. So every time the sound hits back and forth a little between the walls, it creates a little diffraction, a little scattering, and that multiple echo is going to screw up the sound quality. You should make sure there isn't too much of that. Next thing is, are there strong audible reflection paths? Some amount of reflection is good, is necessary. I've talked about that over and over and over again over the course of these webinars, but a really loud reflection is not good. And the way you can find that there's a loud reflection is you play pink noise, let's say on the left speaker, and if there's a loud reflection off the wall here, as you move your head back and forth, the comb filters that get set up change. And as you move further away, just exactly like Jason's doing, thank you for being my actual video.
What about this?
Or that way. And as you move your head back and forth, the pink noise should sound consistent. It should not sound phasey. If there's strong reflections, you're going to hear the sound going, and that's bad. So you can play pink noise from the signal generator in REW. You can play it off the TK51 disc or the Dolby Atmos disc, and you just play it and move your head around and listen for it. Make sure it doesn't sound all screwed up as you move around.
Mm-hmm.
Next element of room verification is background noise. Again, I still haven't started calibrating. I know it's crazy, huh? What we want is a room that's quiet.
Yes.
And maybe you don't know anything about this room and you want to make sure it's quiet, or you helped in the design of the room and you told the ventilation contractor, hey, I need a background noise of NC 20, noise criteria 20. They go, yeah, I'll do that. And you want to verify that that's right. So you're going to do that with a spectrum analyzer and a really good low noise microphone and preamp. Warning, the basic USB microphone with a 1/4-inch capsule, or some of the basic XLR mics, like I think the one you have back there, are actually not low noise enough to get this measurement right.
Okay.
To really do this measurement right, you need at least a 1/2-inch capsule or a 1-inch capsule on a really good microphone with a good mic preamp, or else you're going to fail this test. But you can still squint at it sideways. I'll show you this. So,
are there any specific mics off the top of your head that I could look up for the group and share with everybody?
Yeah, you should get a Brulin Care 1-inch microphone. They only cost about $6,000.
Oh, yeah.
No, there's a bunch of people that make decent 1/2-inch and 1-inch mics. ACO Pacific makes some decent ones, or you can rent one. This is a device that's worth renting because you're not going to use it very often, and you can rent one from many different sources. Get it in. It's calibrated. It all works right with a good preamp. This is a case where you really want the mic and its associated preamp. So now NC20, to be clear, this is the measured noise level as measured on the analyzer for an NC20 curve. This is 10, 15, 20, 25. 25 means that somewhere around the mid frequencies, around here, the noise level is at about 25 decibels. It also means that at low frequency, you can tolerate a much higher noise floor, right there. And at high frequencies, you can tolerate a lower noise floor. And that's because the human ear does not listen at the same way at the mid frequencies as it does at the low frequency. So for the perceived sense of noise, you can tolerate a higher measured level at low frequency because you don't hear it as much. So these are the NC curves. For a really good room, you really ideally want NC15 for really high quality work. For a good room, NC20. For a medium room, NC25. NC30 is like a noisy air conditioner. You should never tolerate that.
Yeah.
NC30 means that some of the quiet passages in a movie where people are whispering, or some of the reverb, some of the surround effects will just get lost in the noise.
Yeah, you'll never hear it. It's like it's similar in video. When the room is brighter than the TV, you lose stuff. So if in this case the room is louder than the system at certain points, same thing. You'll lose stuff. I am constantly at my house. If I'm sitting down to watch a movie or TV show that I'm really excited about, or like season 3 of Dark on Netflix, which does take a lot of paying attention and really listening, that AC is getting turned off, and hopefully it doesn't get too hot in here because I'm prioritizing my viewing and listening experience over my physical comfort at that point. But to me, that movie or that show is worth it. And one of these days when I'm in a room that I can actually have more say over, then we'll do it the right way. But that's just how I have to do it for now.
Right, absolutely. So, and NC0, or the threshold of hearing, is actually a band over here. Ideally, if you're doing a really high class room, and ideally, if you guys are sitting through an hour and 45 minutes listening to me babble on about this, that means that you care. Or if you're watching this on YouTube for this long and haven't decided to slit your wrist for me just going on and on and on, that means you care. Ideally, the noise floor of the room is all the way down here because it's at the threshold of hearing. There's nothing interfering with what's coming off the speakers, and that's really, really, really hard to do. So if you actually manage to get somewhere around here, you should pat yourself on the back, because that's hard enough to do. NC5, I've done it a few times before. It's a ton of work. So, all right. Next verification is, hey, this room was designed with a proper acoustical plan. Did you follow the plan? Did the installer follow the plan? So you look and see whether the absorbers and diffusers are there. Hopefully you're doing that before fabric goes up. You can also tell from the boundary reflection tests above whether it was built per plan. So I actually had a case years ago. Oh, this is crazy. In the category of like, how can people screw it up? So the room was specified. Actually, I'm going to turn my video back on so you can see me. So the room was specified with diffusers that were curved surfaces this way around the front, kind of a little bit like these diffusers that are behind me, but these are 3D and they have a sort of a curved shape. But they were synthetic shells placed on the side walls, and it was specified that way. And I got a picture of the installation that made it look like it was all fine. And I get in the room and I'm doing that test of bopping around. And it's like, what is going on? I clap my hands. There's all these slap echoes. It's like, what? So, you know, I start, the room now has fabric up so you can't touch anything. I start like trying to feel what's behind there. And I can tell that where there's supposed to be diffusers, I'm not feeling the curve of the cylindrical shape. And I'm like, what? And so it's like, I'm sorry, we're going to have to take this fabric down. Pull the fabric down, and sure enough, the diffusers are there. But rather than shell be mounted, I'm trying to do the, rather than be mounted on the wall correctly, the installer put them backwards, actually built.
Oops.
They're laughing. Actually built framing, like actually, you know, some framing behind so they would actually be set off, and then made a whole series of concave shapes in the room. And I was like, yep, they followed the plan, but they didn't follow the plan. And
it's like, oh, you guys were so close.
So close. So these boundary reflection tests and the the clap test will tell you a lot. You should also measure the reverb time of the room at this point, which using Room EQ Wizard you can do. You plug it into the center speaker, run a sweep using the impulse response, and you can see what the measured reverb time is supposed to be, and you can check that it's somewhere around 0.3 seconds across the range. And if it's not,
I'm sorry, are those the waterfalls, or am I thinking of something else?
So yeah, you can look at the waterfalls, but Room EQ Wizard actually shows you a measurement of the reflection decay time, like an actual curve that shows the decay time over frequency in about 4 or 5 different models in how it's actually computing it.
Cool.
So, all right, we're getting close to the end of verification. You guys are going to love this. So if the room was supposed to be sound isolated, now is the time to check that the sound isolation construction was actually done correctly. And what I like to do is, hey, did you follow the plan?
Right.
Talk to the builder. Look for pictures. Did you actually build the walls the way they're supposed to with the right isolators? Did you now put giant screws through the whole wall, thinking that would rigidify it?
Anthony, your camera's
remember to turn off.
Yeah, there you go.
Did you remember to turn off your video so that people can actually hear you? And then I'm going to play a test signal we put in the TK51, which is loud pink noise in all the channels at the same time. And it turns on and off once a second. So, and then I'm going to go close the door, walk around. I'm going to go to all of the neighboring rooms above, lateral, below the room, wherever it is, and listen for that pulsing noise. The pulsing noise has 2 benefits. One is it reduces the chance of blowing up the speaker because it's only working at half the power over time. Even though it's extremely loud at 100 dB, it's playing all of the speakers together, so they're sharing the load, and it's also pulsing. But also the beginning of the pulse is a place where your auditory system can go, oh, it sounds like it's coming from the crack in the wall over there, or from this door, or from this window. Sure. When it's constant pink noise, it's kind of hard to locate it. But when it's actually pulsing on and off, you can actually hear it. All right. Back in the room, we're going to check for rattles. So this is a little similar to checking that there's no buzzes in the speakers, but now we're actually just checking to see that the room is actually free of any rattles. So we're going to play loud single tone sweeps, preferably to multiple speakers at a time. If you can actually switch the surround decoder to multi-channel stereo mode, where all of the speakers are lit up all together, then you can play even louder without blowing up woofers or tweeters. You can also play loud, low frequency pink noise. So either on the test disc, we have on the Atmos disc, there's a test signal for checking the subwoofer that's low frequency only, and just play that really loud and make sure you don't hear anything rattling in the room. And you're looking for light fixtures, speaker brackets, ventilation grills, windows, cabinet doors, decorative trims, anything that could rattle in the room. Okay, and you got to fix them. If you don't fix them, the first time your client is watching a movie in which there's a loud, low frequency effects that's preceding something bad that's about to happen, like they're going to hear the room rattling and like, what's going on?
Oh,
They're either going
man.
to think that's really funny.
Yeah.
Wow, my subwoofers are powerful enough to rattle a room, or they're going to really hate it.
My grandparents have a big at their house, at least they have a big cabinet with a bunch of wine glasses and stuff in it. And man, as soon as there's anything loud in that room at all, the whole thing is shaking and rattling. You can hear the wine glasses clanging together, and I'm like, oh gosh.
Right. Okay, so you showed up in this room. You were contracted to come over and calibrate. As a reminder, you've shown up, you took some pictures, you listened to some music, you configured all the components. You've gone through this entire verification process to make sure that the speakers all work, that the electronics all work, there's no oscillations, the cables aren't bad, yada, 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 yada. Now you know that the system works. Now, if the speakers are in, they're regular in-room speakers, you may need to make sure that their placement is correct, and most of those placement decisions should happen during the design phase. But if they're not all bolted in the wall or behind stretch fabric, you could do some fine-tuning now. For more info on what to do, go look at the webinars on speaker placement. I talked about it until it's blue in the face, and there you go. And look at also the subwoofer webinars on that same topic. So not going to repeat that. This is a quick reminder of where ideally all the speakers should kind of land. And I'm not going to spend any time on this. Screenshots and YouTube or going back to the session on speaker placement will guarantee that, or will allow you to see this. I do want to remind you, though, that ideally the 4 subwoofers are in 4 corners, as much as you can. I want to remind you that ideally you have an acoustically transparent screen with 3 speakers behind the screen. If that's not the case, you're going to be fighting the calibration. Ideally, during the design, all of the boundary effects have been taken into account so that the low frequency errors between the speakers and the wall reflections have been considered. And that means that all of the reflected path lengths are all different so that there aren't repeated errors. And then if you can, like I said, you can fine tune during calibration, which is to move the speakers around, doing what sometimes people refer to as placement equalization. So you're going to put test signals in the speakers, you're going to measure them, and you're going to move the speakers around and see if things get better by moving them. You're going to verify phantom imaging between the 2 speakers. So you're going to do signals that are in the left and right at the same time, and verify if by moving the speakers closer and further from each other or in and out of the room, you improve the imaging. And in doing that, you're going to make sure that you don't put the speakers too far away from each other, that the separation is now lost. Or you get better separation, but the phantom imaging is lost. So all of that's called tinkering time. If I'm going to work on a system that's not all internally integrated, I'm going to schedule another 2 hours to move speakers around and see if I can do things better with some placement EQ, because that is better than just forcing it through electronic EQ.
Oh yeah, sure thing.
Part of the speaker thing, though, is to make sure that the aiming and the coverage are correct. So this is another element of the calibration and configuration. It gets its own 4 or 5 pages of module in my checklist. And the main idea is by using pink noise, you're going to verify and measure that all of the seat positions have the same and consistent sound. I've talked about that a few times during the sessions. And I don't need to go over that, but you just want to make sure that vertically the speaker is aimed at the right position. I'm going to turn the camera on again here so you can see what I want to say. So the speaker may want to be aimed up or down so that make sure it's covering all the audience correctly, and the left and rights may need to be towed in to make sure that they're covering the audience correctly. And I talked about that at the last session quite a bit.
Yeah, the sweet spot session had a lot of this specific topic in that session as well. So that'd be another one to reference here too.
Right. So if you are confronted with this speaker, I talk about this almost all the time. This is like the biggest vile thing that I see in cinemas is a speaker that's called a center speaker. It's 2 woofers with a tweeter in the middle. Those things have a horrible lobing pattern in the mid frequency. So between 1 and 2 kilohertz, the way they radiate out sound looks like this 5-leaf clover. This is just a very simple model. It can be very different. But that does mean that somebody's going to be sitting in a hole of that speaker, and you'll probably never be able to calibrate the room to sound right with this if it's a speaker like this, because at the main seat position it could sound good, and one seat over to the right it's not going to sound good. And you go, well, what do? Well, see if you can turn the speaker around. See if you can convince the client, the installer, whatever, to switch to a speaker that's a better solution, which would be a 3-way speaker with 2 woofers, mid-range and tweeter, or a 2.5-way speaker in which one of the 2 woofers is dropped out at the mid-frequencies. Now, realize that all speakers are going to have some directivity pattern. So this could be the lobing pattern of a regular 2-way speaker at the crossover region. So right when the tweeter and the woofer are playing together, and you got to make sure it's aimed correctly. And so how do you do that? Maybe it's 2 of you people. You and somebody else. One person's aiming the speaker up and down in the room, and you're sitting listening. Or you aim it where you think it's got to be. You go sit down, and you sit at the seat position. You stand up. You sit back down. You crouch down, and you make sure that you're not in the hole.
Yeah.
This hole at the crossover region at 2 kilohertz is going to make dialogue very unintelligible.
Is it safe to? I've done this in the past. I've used like a laser pointer to kind of get my rough adjustment, and then I'll do an auditory test to really fine tune it. Is that a fair way to do it?
Yeah, you can. So the laser pointer would be on the speaker, sort of aiming out at the speaker. But I also find that just by going to the speaker and like looking at it and kind of looking at the parallel lines of the speaker and pointing at the listener,
you'll get close enough.
You'll get close enough.
Cool.
So
all right, good.
Beware of these what's called Diapolito speakers. Again, I've mentioned this before. This is not a thing that Joe Diapolito intended to be a problem. And the reason those speakers are called Diapolito is he wrote a paper that explained how these work and what the benefits and disadvantages are. So they put his name on it. It's the wrong person to blame.
That's not a brand. That's just like a speaker style.
It's Joseph Diapolito.
Right.
Nice Italian boy. Who's worked for a number of different speaker companies. For a while, he was working at Snell and a few other companies. But it's a style. It should really be called a woofer tweeter woofer speaker stacked this way. Those have the same lobing pattern than the other one, right? That's the same thing as this.
Notice yeah.
And you got to make sure those are aimed. Bottom line is you got to play with the aiming on that. All right. So know that some of the waveguide driven speakers have an intentional beam that's pointed down, or wherever it's pointed to. They tend to work better because the crossover is much better controlled. This is a picture of our Grimani Systems S. That thing is actually intentionally pointed down at the listener, so you don't really have to aim them because they're made to be right, because we thought about it ahead of Okay. Now, 2 hours into this, I can start talking about what you think is calibration. Finally. Crazy, huh? Should I keep going?
Oh yeah. Yeah, we've got
You sure?
Yeah, everybody's still on. We've got lots of great questions too, guys. By the way, keep those questions coming in. There are a few questions that have come in so far that are very kind of specific. So I'll save those for an email, but guys, keep those questions coming in. There's been some great ones so far.
So we have 2 choices. I'd love to just keep going because I have about another 20 minutes to finish this out, and that will be. Guys, I was really hoping that this last session would just be 1 hour, and I tried, and you have no idea how many slides I cut out of my calibration course. This is half of what the calibration course is normally.
Right. Which I think is another good reason why we should do some advanced little deep diver courses, like what we talked about before. But yeah, everybody's still here. Everybody's saying go, go, go. So yeah, everybody's excited.
Every time you see this slide, which is the next module, that could easily be 2 hours.
Exactly.
Easily. So level calibration. That's what you guys have all been doing, hopefully, for the last 25 or 30 years. Sorry, I just picked my microphone. That's using the internal test tones inside the surround decoder. All surround decoders since 1987.
Yeah.
Is that correct? I'm thinking back here.
I mean, the first ones I ever played with in the mid-90s had it, so yeah, sure.
So before ProLogic, we didn't put test signals in there. The minute ProLogic came out, Roger Dressler and I, at the time at Dolby, said, yep, we got to have some test tones so people can calibrate these things. So all surround decoders have had those, okay? So there's no excuse to not use those. They are usually mid-frequency, band-limited signal. It's not pink noise. It's actually pink
Right.
noise in which everything below 500 hertz has been cut off. Everything above 2 kilohertz has been cut off. And that's just so that it's two benefits in that. One is it's easier on the ear. It's easier on sound level meters. And it's also the region in which your auditory system is most sensitive to sound levels. So it's a way to do a better job. If somebody's going to try to calibrate level with wideband pink noise, they're about to make major mistakes to the tune of 3 or 4 decibels of error because of low frequency conditions in the room or the microphone, and high frequency conditions in the microphone. And I still see a lot of pro audio calibrators in cinemas calibrate with wideband pink because that's been the standard. Wrong. Yeah. Wrong. You will be off. So mid-range pink noise. Well, guess what Dolby put in the Atmos test disc?
Same thing?
Wideband
Oh, they
pink.
went wide.
I'm like, when that thing came out, it's like, oh, really, guys? Come on.
You were so close.
Oh, come on. So a way around that, by the way, is you can use wideband pink and set your SPL meter if you're using one to the A-weighted mode.
A-weighted, yep.
A-weighting is going to put a filter on this. You won't be able to rely on absolute level to be correct, but at least the relative levels will come out correctly. So you're going to lose about 3 dB of sound pressure level, whatever.
Is there any way to tell this, by the way, that the generator in the AVR or the pre-pro or whatever is narrowband versus wideband, or do you just have to kind of know that? Or
99% of them are narrowband.
Okay.
Some of the higher end ones give you the option of wideband or narrowband. But the real thing is if it sounds like it's got a lot of low frequency, like some rumble and some,
it'll rumble, yeah, right, exactly.
It's wideband.
Yeah.
The way to tell is hopefully by now you actually have a spectrum analyzer in your hand. You're using your USB mic and Room EQ Wizard, and when you play it, this test signal, it should just be this like little narrow thing in the mid range and not wideband. So that's actually a good question. Actually, all your questions are good, Jason.
Oh, well,
that one was particularly good. So the test signals are in different surround decoders or in different places. Sometimes they're in speaker levels, channel levels. They hide in menus in all kinds of different places. Sometimes they're right available at the push of a button on the remote control, which if you hide the remote control from the user, that's perfectly fine. That used to be how they often were in the early days. And that's a little dangerous because if the client's poking around using the original remote control in the dark with their friends, suddenly they hit the button, and instead of hearing, the moment with all of the important information, they're hearing. Now, ideally, the internal test signals are correctly calibrated electrically internally, so that what you're looking for is a 75 dB sound pressure level on your sound level meter, ideally. And you hold your sound pressure level meter at arm's length over the seat position, so not right in front of you, not at your chest, but holding it out with your arm, or you put it on a mic stand so you're not holding it too close there.
I get this question all the time, so great to ask you as well. Am I holding it like this and the probe is facing up, or am I facing the front of the system?
Yeah, so that's a good question because
I get it all the time.
Yeah. Because the signal stops at 2 kilohertz, it doesn't go up much higher than that. And because the microphones in those meters are essentially omnidirectional microphones, it doesn't really matter.
Yeah.
Putting it straight up is probably the easiest way to do it. Kind of holding it straight up, because then what you've got is all of the speakers all the way around you are hitting that microphone just fine. It's what I just said does not apply to frequency response measurements with Omni mics, but just for this sound level, it doesn't matter.
Right.
So you are relying on a sound level meter to tell you the number, but you should also use your ears. So when you're all done going around the room and getting that number to say 75 on the meter, you should listen. So now put yourself on the seating position and listen all the way around and make sure the levels sound consistent. And take averages. Don't just measure it at one location. Like move the microphone around, especially for the surround speakers, and especially also for the subwoofer. It will change from seat to seat because of standing waves. You want to make sure you get a good area average. Low cost meters are okay for this. What I call a low cost meter is that thing you just brandished there, the Radio Shack which I don't know. I don't know if they still do. They still make that even at this point? I don't know.
They may have rebranded it. I'll check while you're going.
All
But
right.
you know, I used to have the analog one, the one with the
Yep.
with the needle, and I really loved that one. But man, over the years, who knows what happened to it? But I just got the digital one now. It works great.
Yeah,
I'm
the
a
analog
nerd,
ones,
man.
the
I like
needle, the needle mechanism would get broken through
yeah.
falling. Now we used to check those at THX for years and years and years when we were doing the calibration, the certification courses, and they were usually
Right.
within a dB or two of accurate, which is amazing for a thing that costs $39. There are plenty of meters on the market you can buy for, between $20 and $20,000. I would spring for something around the $40 to $50 range, and it'll probably be just fine. All right. Now, if THX is doing its job correctly, the internal test zones are actually accurate for that 75 dB target. Otherwise, you don't really know. And so what I do recommend is you get a reliable test DVD. The 5.1 toolkit actually has the test signals very carefully calibrated in there. And so that's where you want to set that up. Now, there is a concept called dialogue normalization in surround processors, and that can throw you for a loop because that is I don't have time to go into it, but it's a thing that automatically turns the volume up and down based on program material as controlled inside the metadata of the Dolby Digital stream. And some test discs are recorded with it and some are not, and you'll have these 4 dB differences between different test discs. So you got to look out for that.
That specific Radio Shack SPL meter, I cannot find it. There's like kind of a newer one that's a little smaller, doesn't look like that one, but there is a Radio Shack SPL meter out there, but it looks like this particular one is probably only going to be found on the used market, most likely.
Right. I should go and get one of those and check it out. Like I said, in the past, the factory that made those somewhere in China did a really good job of calibrating them. It's not that hard to tune them. You just got to have the right calibrator.
Yeah, sure.
So I don't know if the new ones are good or not for that. All right, next thing in the level calibration is there's interestingly enough, on a lot of surround decoders, there's the ability to change the level of the LFE independent of the subwoofer output. So this is not the subwoofer gain, but the 0.1 channel, internal 0.1 channel gain and how it adds into the other channels. And there is no reason to change that. There is a standard, there's a reference that signal should be added in 10 dB louder than all the other signals into the summation. There's no reason to change that. For some reason, probably feature set, manufacturers can let you turn that down. The only reason I can think is, hey, if a client doesn't want loud bass ever in their system because they get freaked out by it or they don't want to wake up the kids, I guess you could say that the loud low frequency effects that are usually recorded into the LFE, you could turn those down. But that's not reference.
It's a rare instance, it sounds like,
Right. And so you want to check that that's done correctly. You do that by using a test disc that has an LFE test signal on it. Whoops. Keep hitting the button here. So the 5.1 toolkit does have a series of tests that show here's low frequency in the LFE only. Here's low frequency in the center. The same low frequency, it should come out at the same level. It's actually offset by 10 dB between the two. This is another example of how this course really needs to be 2 days long to explain all those things. But you do need to check this because I've been to systems where people are complaining there's not enough bass and we keep turning up the subwoofer and the bass is not enough and you did a terrible job and blah, blah, blah. Everybody's like mad at everybody else because the client really wanted thumping bass. I go into the menus and I see that the LFE's been turned down 20 dB. Well, of course you're not going to get any bass, dude. It'd be like saying, the color on this TV has no pop. It's like, it's a $20,000 projector and there's no pop. And you go in there and you see the saturation is at -20.
Yeah, you're like, no wonder.
Yeah, you're right. Well, if you like black and white movies, it's really nice.
Yeah, sure.
All right. Anyway, and now finally we get to the final, what you think is the final phase, not really, but what's known as equalization. I call it frequency response calibration. So most people think we're going to start here, and we're not, because we're going to spend an entire day doing everything that we had to do before that so that it enables this process to be good.
Right.
Okay. Now, the good thing is, given the audience who's listening, I think I don't need to explain every step of that. You're going to put out signals into each speaker one at a time. one speaker. You're going to measure it with Room EQ Wizard or some other analyzer. You're going to use either the impulse response or the transfer function, or the pseudo-random pink or regular pink. That's all known. There is a function in Room EQ Wizard that allows to take a 12. I am going to ask you to always measure with 12th octave resolution, which means that it's going to look pretty raggedy. There's going to be a lot of little peaks and dips all over the measurements, but then you smooth that out using what's called a psychoacoustic smoothing, which is a computation inside the program that smooths out the peaks and dips to make them look like a more consistent looking curve.
Sure.
But it does so really intelligently, getting rid of really narrow dips and smoothing those up and weighting the value of a peak so that it all looks to your eyes the way it sounds like to a listener. And that psychoacoustic smoothing curve is quite accurate and a very, very good computation. So, all right, first step we're going to do, if you can, is you're going to optimize through placement. Like I said before, you're going to measure the speaker, again, using either pseudo-random pink or sweeps with impulse response. There's a bunch of different ways to do that. That in itself could be a 2-hour session. And if you can move the speakers around and see if you can make them a little bit better by just bringing them in a few inches or pushing them out or in a few inches, sometimes you can improve real big problems. And then you're going to equalize to a target curve, which is that you're going to go into an analyzer. Typically 99% of the time today, it's going to be a digitally controlled device. It's a digital device that you control through either an on-screen menu or through a laptop. And preferably, you're doing that using parametric equalization. So I'll talk about that in a second. Now, a lot of people go, I'm never going to use equalization. It screws up the phase of the sound. I heard. Don't worry. Be happy. It's good. It's all good. Now, if you're willing to go beyond the I heard, and you're willing to listen to me for a second, hear this. Any equalization you're doing electronically to compensate for what's called a minimum phase event in the room, which is an error from the room, is actually compensating the amplitude response and the phase response of the room. Okay, I'm going to say that again. If there's a peak in the room of, I'm giving you a really nasty example over here. If there's a 12 dB peak in the room at 200 hertz, there is necessarily, if it's a minimum phase factor, something that is a normal reflection or standing wave, the phase is also going to be rotating around. You cannot have a peak in amplitude response without a rotation of the phase under most conditions in rooms. If it's a reflection, the mere fact that you're thinking of the sound coming at you being followed later by a bounce off the room that's adding signal into it, that bounce is out of phase. It's rotating, it's in a different phase, it's at a different time. It's rotating the sound, the time domain around. So if you realize that the room errors will have amplitude and phase errors, because you can't really do it without that. Where here I show a theoretical phase error. This is a computed thing where this is a 12 dB peak. This is the phase character of a 12 dB peak. Starts off with no phase error, goes all the way up here. This is 90 degrees, it's 120 degrees, goes all the way 120, and then rotates around. You can't see the continuing phase, so this actually shows a rotation around. That is what's going to happen. So if you put a compensation EQ on that, which I didn't draw in here, but if you actually do the inverse, the phase of the compensation is going to go in the opposite direction, and you will linearize both the amplitude and the phase error. So I hear this all the time. Oh yeah, equalizers introduce phase, they suck. It's like, well, yeah, if you don't equalize the right way.
If you don't do it right, yeah, exactly.
If you don't do it right, let's say there was a peak here and you did not measure it right, and you put the dip right here because you didn't measure it right. Because you didn't have the resolution, because you weren't paying attention. Now you have a phase rotation that's going up and down, and it's a royal mess. But if you're careful about it, you can fix it. And with Room EQ Wizard, you can actually look at the phase response of the system.
Nice.
So you can measure it.
So easier.
Right. So you can measure it and you can see it's all screwed up, and then you can equalize it and you see, hey, did I get any better?
And again, you just do the opposite, right? So they cancel out. Yeah.
They cancel out. So now, in measuring, it's really important to do what's called spatial averaging. And that is the idea of taking at least 4 microphone locations in the room. Here I've shown microphone 1, 2, 3, 4. I actually usually put microphone 1 right in the middle of the room, and then 2 over here, 3 over there, 4 over there, whatever. It doesn't matter that much, but you want to measure more than 1 microphone location, or else you have no idea what you're measuring. You're measuring a quarter square inch in space. And
right.
The rigorous way to do that is to plug the 4 microphones into what's called a multiplexer, which is a device that switches between the 4. It's low noise. It may have a preamplifier built into it. The output of that multiplexer then goes into your analysis system. So this is a device. This is a device that AVPro Edge actually sells. So this is the second time in the entire, 6 months that we've been doing this, that I can actually plug a product that you guys make and sell. Thank you very much.
Basically, yeah. That's
the rest of it.
That's actually branded a Meridio product. Yep.
A Meridio. Okay.
Yep.
So the whole process. I'm just drawing a picture over here. Something is going to generate. I wrote pink noise, but actually it could be a different stimulus. That pink noise goes into the equalization system, feeds the speaker. You measure the speaker. You look at the error, and you manually keep adjusting this until that looks like the right curve. Okay.
Right.
That's the process. So I think you understand that. So this is the plug for you guys. Thank you very much.
Thank you.
Now, you really want to equalize all of the channels. You really want to do that for all the channels. If you can't, at least you got to equalize the left, center, right, and subwoofers. Okay, that's the minimum.
Sure.
Ideally, you use a 10-band parametric EQ, which is a device in which each band you can adjust the frequency, the bandwidth, and the gain. If you can't get your hands on a parametric EQ, if all that you have is what's called a graphic EQ, which is a slider per frequency, at least make sure that's what's called a 3rd octave EQ. So there's 3 bands per octave. So it's a thing that if you actually look at the frequencies available on there, it'll say 25, 50, 63, 125, 250, et cetera, et cetera, et cetera. And so that's what you want for all of the main speakers, and 1/6 octave for the subwoofer. If you don't have that level of resolution, you're not going to be able to fix things, and that whole amplitude and phase thing I showed earlier is not going to get right.
It won't matter, yeah.
Other requirements is you want a pink noise source of some sorts, or a sine wave sweep using impulse response that you can actually feed to any one of the channels for the crossover. So that's usually done with a test disc. I forgot to write on here that that's also available from the Dolby disc.
Yeah.
So let me actually indicate that here. It's a Blu-ray disc.
I have so many of those demo discs and test discs. I've got like 12 of them up there, and I'm trying to remember if I have that specific one. I think I do, but they're out there if not.
I see them on the YouTube market, which is sort of fun.
Yeah, I'm gonna look right now.
It's a giveaway. It's a giveaway, and people sell them. It's like, okay.
Oh yeah, right.
So pink noise is one way to do it. Pseudo-random pink noise is a better way to do it. That is available in REW. If you're going to use it in REW, of course, how do you get that signal into your sound system? Well, if your laptop has an HDMI output, which is pretty common, you can plug that HDMI signal right into your surround decoder, and you can feed the left, you can feed the right, you can feed the left and right in phase, and put the decoder in the Pro Logic mode, or you can put the decoder in the 5.1, the 5-channel stereo mode that feeds the same signal to all the speakers, and disconnect or mute speakers one at a time, leaving only the one you want to calibrate effective. And that's really the best way to do it. How do you get the HDMI signal off your laptop to a surround decoder that's 3 stories down? So the way you do that is you either have a USB bail-in, an HDMI bail-in and a really long Cat5e cable, or if you planned ahead, there's an actual game port, quote-unquote game port, or a way in the room to feed that signal. Usually 1 or 2 Cat5 cables is all you need to be able to make that happen. Other requirement, of course, is you need some kind of an analyzer. If you're going to use pink noise or pseudo-random pink noise, you need to be able to do averaging over 30 seconds so that you can have your 4 microphones switching around through multiplexing. And it needs to, like I said before, it needs to be 12th octave resolution. And, you know, again, free plug, REW has all of that, and it's hard to beat. And it has that and more. So other things to remember are, if you have known good speakers that have a good axial response and a reasonable sound power, and you know this because you've asked the manufacturer for the frequency responses and the sound power curves that I showed you several times in these sessions, the spinoramas, you really theoretically don't need to equalize, you don't need to touch those above 1 kilohertz. You may see errors in response, but those errors actually may be something that your auditory system's not hearing. So that's one thing. Next thing is you always want to equalize the left, center, right, and subwoofer output separately. There's equalizers out there inside surround decoders that force you to do the left and rights at the same time, and they're going to be different. Even if the room is symmetrical, they're going to end up being different. So you want to make sure you have individual controls of these things. This is a little illustration as to why you should only equalize above 1K. So if the speaker is a decent speaker with decent radiation pattern that says decent sound power, your auditory system listens to the direct sound above 1 kilohertz mainly. Below 1 kilohertz, the reflected sound becomes more and more important. And below 150 hertz, it's the modal, the actual standing wave characteristics that matter. So really, you should be, when you're thinking of EQ, you should be thinking that you're working from 20 hertz up to 1 kilohertz and not touching anything above that. If you're concerned about what's going on above that, I would go back to the near field response measurements that I talked about, what is it, an hour and a half ago?
Yeah,
where you're actually checking that the speakers are right. Make sure that those near fields are all smooth response. So generally, if you do this, you'll stay away from trouble. If you want to take the liberty to adjust broadband things through what's known sometimes as the messy middle or the high frequency, you could, but I would wait till a little bit later. Make sure to turn off all enhancements during EQ. So THX mode, DSP cinema, dialogue boost, bass, treble, all of this stuff should be turned off so that you're not equalizing against it. And yes, the surround speakers may need EQ depending on their placement and depending on the grade of performance you're trying to do in this project. So I've talked about the spatial averaging. You should really set up 4 microphones somewhere around the main seat locations. There's theories that say that one should be like far outside of the main seat so you actually get an average of the room. That's true too. Yeah. And you want to make sure that the mic capsules are close to seated ear location. And you generally, for the front speakers, you want to point tilt the mic capsules forward. Usually 45 degrees is all that you need. You don't need to point them straight at them, but forward. And then when you get into the surround speakers, maybe turn the mic so that they're, again, 45 degrees, tilted down a little bit towards the sides, the backs, etc. If you don't have a multiplexer, because you're being a cheapskate or you didn't want to carry too much stuff with you, and you have just one microphone, or if you're doing impulse response measurements, you need to move the microphone to the 4 locations. But I actually would tape down somewhere on the location, put on the floor with some painter's tape, where the microphone was, so that you are repeatedly going back to that placement as you're successively doing the measurements. There's a thing I like to do is what I call the 2-year average, which is I like to put 2 of the microphones on the main seat if I know there's going to be a real focus. And I know we talked about this in the sweet spot business. Sometimes there is one main seat where you know the person's going to sit. I like to put 2 microphones 7 inches apart, and I use a stereo mic clip. So this is a thing for recording where you have this metal bar and a location for 2 mic clips, and you can put 2 mics on there. And I'll do that 2 microphone location at the main seat, maybe one to the left, one behind, etc. And doing that is even higher resolution because you're not just putting a mic at the nose of the listener, but you're actually spreading it to the listener ears. And when you're getting to that level, you're really geeking out. Right? And those little geek out things I'm going to start talking about are what takes you the last few percent.
Right.
All right, let's go through a little procedure here. You're going to feed pink noise or your test signal stimulus to the left speaker. You're going to measure for about 20 seconds with spatiotemporal average. You're going to save that curve, if you're using Room EQ Wizard, you actually hit save and you say this is my left channel original response or no EQ, and then you're going to try to equalize. When you're going to go grab the bands of equalization, first remove the big peaks. Don't try to push in troughs because they may be the result of a cancellation and you can't fix that. So you're going to remove the big peaks. If there's a tilt in the response where the entire response is pointing up or down, you may smooth that out. You should expect a roll off somewhere above 6 or 8 kilohertz, depending on the size of the room and the type of speaker. And ultimately, you're going to be equalizing to a target curve. So let's talk about that. So the target curve is actually a shape of the frequency response that has been found to sound right when using omnidirectional microphones, when using speakers with non-flat sound power, which is the majority of speakers, and when using your ears and brain. Again, we're about to get, this whole thing is all about getting the speakers to sound good. And your ear-brain system listens to direct and reflected sounds differently than the way a microphone does. A microphone takes it all in.
Sure.
You can actually filter them out with REW by having a continuously varying window, where as you go up in frequency, it's a shorter and shorter window, so you're getting more and more just the direct sound. It still doesn't match what the ear brain of a human being does. And if you are, if you actually equalize for a flat line, one that's the exact same level at all frequencies, you will fail. It'll sound terrible.
Yeah.
Because the combination of all of those things and the fact that the room has uneven frequency decay means that the target curve is not going to be flat. So there are many variables. So this is the most common target curve. I tried to do this with a drawing in PowerPoint, didn't really come out. But what you're trying to get to is, first off, is a curve that throughout most of it, so from about 200 hertz up to about 6 kilohertz, is a very gentle downward slope, about 1 dB per octave. And then below 150 hertz, you want to see some gain. You want to see about 5 dB extra low frequency than in the mid-range. And above 6 to 8 kilohertz, you want to see the energy tapering down. It's not like you want it to cut off, but you want it to start falling off at 6 dB per octave. If you get that out of your microphones and analyzer, chances are the room's going to sound pretty good. If you were to equalize for a flat line, it's going to sound hissy. There'll be no bass. It's not going to sound. It'll be, well, you would say, well, it should be flat response. The electrical response should be flat. Yes, but all of these variables, including the fact that your ear brain does not listen to the sounds the same way as an omnidirectional microphone. They actually do listen flat. The ear brain does listen flat, but it does not listen the same way as a microphone does.
Sure.
A microphone measures flat. It has no discrimination between the direct and reflected sounds. It is omnidirectional, so it's picking up the entire room, so the overall sound power of the room. And all of that, all these factors all lumped together mean that if you do anything else than this, as a curve, you may end up with the wrong sound. Now, I also do want to say that this doesn't apply to every room. If you start with a room that has the proper reflection decay time, because you've designed it right, and you verify that it's right, for dramatic effect, I'm going to turn my camera back on so I can do a little pointer. So, number one, you have a room that's got the right proportions to standing range. You put the right amount of absorption and diffusion so that the reverb time, the reflection decay time, is smooth with frequency, maybe rising a little bit at the low end. Number three, you have speakers that have really good sound power. So the way they radiate out in the room is even at all frequencies, all the way around, constant directivity. Then if you do all of those things, you can get to a really high level of certainty that this target curve is going to give you really good sound. And maybe with all of those things, the top end would droop off a little less. The bottom end doesn't have to be as loud because you've taken care of the entire bubble around the speakers and the human head and the microphone, so that it's actually more like flat response.
Is there a name for this curve, or is this something you've come up with, or no. How do we reference this curve?
So that's a really good question. wait for the focus to catch up. Come on.
Oh, under focus.
What's known in pro audio as the house curve.
House curve, yeah.
The house curve has been practiced for years and years and years and
Yeah.
years in professional audio, which is, you should have a little tapering of the high frequency response. What's known in cinemas as the 2969X curve, which stands for extended response, which doesn't look like this, by the way. It's a group off starting at 2 kilohertz, and it's for totally different reasons. What I like to refer to as the Toole, Olive et al., their buddy Al, curve, which is the result of their research on listener preferences. So Floyd Toole, Sean Olive, and 2 or 3 other guys at work, and that what sometimes we refer to as the Canadian mafia of psychoacousticians. Jokingly, of course, we love you. They took time to go, hey, listeners in many different rooms, listening to lots of program material. What do you like? Let's draw a bunch of different curves for you.
Yeah.
On the analyzer, and let's see what you like. And what they found is, in most cases, people like this. There's actually a new representation. It shows us a little flatter, depending on the type of speaker, depending on what you want to read. So if you want to read more about this, there's Audio Engineering Society papers that outline this. So not new data. I did not come up with this. I confirm. So I've always been doing some kind of room target curve, but it was not until a seminal paper from, it's definitely more than 20 years ago, probably 25 years ago, by Sean Olive, that showed, hey, here's the latest research on our psychoacoustics and what people like, that I would say, yeah, this curve got kind of formalized.
Very cool.
And let me stop my camera again. All right, can you see my
yes,
screen?
Yeah, we see your PowerPoint. Right. Yep.
So this is the target curve we're trying to get to. And this is what it would look like as you're in the process with Room EQ Wizard to get there, which is a bit of rise at the low frequency, and like a gentle slope. This is a thing I was doing yesterday. It's not quite done. And by the way, this is plus and minus 1 dB. Here is the slope, plus and minus 1 dB. This is getting pretty close. To finish this up, you would want to smooth out this little bump, maybe put a little bit more taper, whatever. I just wanted to show you something that's not just a drawing done PowerPoint, but an actual measurement. So, all right. So you're going to dial in the correction settings. You're going to remove peaks. Try not to correct much more than plus and minus 6 dB, because if you are, there's something really wrong. Maybe it's a bad speaker. You need to fix it. And you do the correction and you remeasure. You make sure that as you're correcting, you're getting to the right result. Once in a while, you're going to try to pull down a peak or bring up a dip, and you put it up 4 dB and it didn't work. So what happened? What is it that did? What is the effect that does that? You have a 12 dB peak, for example, which is really unthinkable, and you pulled it down 12 dB and it didn't go down 12 dB. That happens. And that happens when the error in the room is what's called non-minimum phase, which is that things are unpredictable in the amplitude and phase and it's not working out. And so you need to be able to see that. Don't just rely on the fact that you're going to draw the inverse curve and it works out. So the better auto EQ systems look at this stuff in the time domain, and they actually look at the relationship between amplitude and time and only give you corrections for the ones that are correctly controllable. So ultimately, you're trying to bring this to where your results are plus and minus 3 dB from that target curve, which is really, you could go to plus and minus 2, you could go to plus and minus 1 if you wanted to obsess over it. But by the time you get to plus and minus 3, it's just like in video where you get to within 2 or 3% of the 323.329 or 313.329. It's close enough, right? So I usually do this in 3 or 4 iterations: measure, correct, measure, correct, measure, correct, gradually fine-tuning the EQ to get to the target curve. I move cautiously. I don't grab big bands and slam up and down. Just take it easy. You may want to save the first correction curve as EQ1, then you do the next one and you save it as EQ2, and you overlay them and you look, hey, did I get any better? You may do this one more time, and you may want to do an EQ3, EQ4. However many times you need to go through this. I tend to keep all this data to show the progression, see if I'm actually getting somewhere. And also, as a final report to the client, you can show them the successive process you took.
Anthony, and when you're doing this, when you're making the EQ adjustments especially, like in video these days, I can usually, in some cases, I can control the television from the calibration software. Are there any instances like that in the audio world, or are you just holding the remote in your hand and going through the EQ portion of the AVR or the EQ of the EQ and manually just up, down, changing frequencies, things like that?
Yeah, there's various versions of that. So on one side, it's completely manual, and it's not really the remote of the receiver, but it's actually a computer laptop with an application tuning the digital EQ.
Sure.
And so you're going there manually. So that's on one end of the spectrum. The other end of the spectrum is completely automated, where you tell, be it Dirac or one of the other compensation things, hey, measure this, do what you think you got to do. I'm going to go over and get a cup of coffee, and I'll come back.
Yeah.
And with the better ones like Dirac, they do a pretty good job, and then you can listen to it and you can go, I didn't really like that. In most cases, you're not going to like what they do, because they're going to draw a perfect target curve,
right,
which may not be right for that loudspeaker, that room, your taste, that day, whatever it is.
Yeah.
And with some of those, you can change the target curve. With most of those audio EQ systems, you can't go in and manually change the bands, but you can go, I didn't really like the way that sounded. It's a little dull. I'm going to change the target curve to have a little less high frequency attenuation. And you can tell it to recompute, and you can listen to it.
Cool.
Some of the audio EQ systems, you measure once, you tell it to do its thing once, you get one result. And if you want, you can actually measure the result by using your own analyzer, and you push the button again and you get a different result.
Yeah.
And you push the button again, you get a different result. That's a bad auto EQ system. Some of the better ones behave just like the DCI grade video ones, where you give it the red, green, blue, and white, and bam, it gets exactly right down the target perfectly. So it's a little bit all over the place. My view on it is, if you're doing high quality work, the client deserves that you are doing this carefully by hand, kind of like cooking food, very, very just putting your best education and intuition into the thing, carefully listening as you go along and massaging it manually. Believe me, I don't really relish having to adjust 15 bands of parametric for every speaker. It's kind of a tedious thing, a lot of dragging, and I would prefer to have a kind of an automated EQ driven system, but I haven't found them to work very well. I'm going to go back though to my preferred one, which is in REW. I had shown you that earlier. There is a way to ask it, hey, REW, how are you? Tell me what bands of EQ you think I should do. And if you're interfaced to one of the equalizers it has in its database, it can actually push that directly to the EQ, just like in video, where you do the measurement and you say, okay, here's my data, shove it in, and it'll correct automatically or semi-automatically. And then you can do manual adjustments if you want. Now, we're not done yet. Now we've tuned our left, our center, our right, and then I highly advocate you do the audio equivalent of a optical comparator, which is, I call it the acoustic comparator, which is I bring out my Etymotic, what's called the ER4S in-ear reference headphones. Again, that's what I have it plugged into my ear right now. Those stick almost perfect spectrally accurate sound right down into your ear canal with a compensation for the typical head-related transfer function. And you listen to pink noise over your headphones. Here, I'll turn my camera on again. People can see me. So I'll play pink noise into my ears with the actual thing plugged into the output of my.
We're losing you on the video again.
So there's a.
Yeah, sorry, it's not working out too great with the camera today. There you go.
I'm giving up. I'm giving up. Okay, so I will listen to pink noise in my ears, and then I'll pull the headphones out, listen to pink noise from the speaker, push the headphones back in nice and snug, listen to the two. They should sound reasonably similar. Okay, reasonably similar. They're never going to sound exactly the same. One's an anechoic response, the other one's an in-room response, but they should sound reasonably similar. If they do, you've done a really good job. Okay, so that's the idea of using those guys as a comparator. You can also listen to music. Listen to music on one speaker at a time. Listen to them on the headphones and see what does. Move on to the next speaker. Now, when it's all said and done, before I go any further, when the left, center, and right I equalized, I listened to pink noise going across the three. So on the 5.1 audio toolkit, there's a test that puts pink noise left, center, right, left, center, right, left, center, right. It doesn't say it, it just plays it. And you can compare that the three front speakers sound reasonably close. I got to warn you, pink noise is a very sensitive test. You'll hear errors of 1 dB. So you may go, oh my God, this is horrible. Take it with a grain of salt. You can obsess about it until they sound exactly the same. And by the way, you can overlay the curves of the left, center, and right speakers and see that they're exactly the same, and you listen and they sound different. What's going on? Psychoacoustics are going on, which is the way you're perceiving the balance of low, mid, and highs is not the way the microphone's measuring it. So what do? Well, if you want, you can go now grab bands of equalization and try to adjust things manually, probably in no more than 1 octave or 2 octaves at a time, like a really broad band of parametric, and actually tweeze these things until they taste the same.
Sure.
Okay, that can be half an hour of work. Forgot to say this. Yeah, you can compare the curves. It may look like a perfect match, but not sound the same. All right. So you fine adjust to make them identical. If you've done any changes, save that as EQ3, and so on and so forth. Now, by the time you're done equalizing all of the speakers, you have changed the gain of the speakers. You've taken out some bass, you've changed the mid frequency, and so you're probably going to need to go back and reset the calibration. So that thing we did now, what would be probably 3 hours ago in an actual system, you're going to have to go back and check the levels. And you want to check that either with the internal test tones or with your test discs. You may also want to retest the headroom. So a long time ago, we threw a bunch of pink noise at the speakers, made sure that they could play it. We threw some pink noise at subwoofers, made sure they could play it. Well, if your speakers ended up with a measured result before you equalized with a boost of 6 or 7 dB in the bass just because they were close to boundaries and they had some extra gain, and you pull that down, guess what? Your speakers are going to play louder. Cool. If, on the other hand, your speaker was lacking some bass, and you pushed up 3 or 4 dB low frequency into the speaker, you're going to have less headroom. And so you want to know what the headroom limitations are. All right. At the end of all this, it's a good idea to measure the frequency response of your equalizer. If it is an analog one, you just plug the measurement right to the line output of your analyzer. And you do that in case your client has come back and started to change all the dials around on your graphic EQ. And I said, for easy recall, when the client has improved your settings, smile.
Improved your settings.
Or if the equalizer fails. You don't want to have to redo everything we just talked about. You can actually redraw the same settings through just a quick measurement until it measures right electrically. Majority of the time today, you're going to be doing this with some kind of digital EQ, so you just save the file. So you either say, save curve, export the data, whatever. Every product has a different way that you save that, but you want to put that in a folder on the server so that when the client changes the settings, or if you want to check and see that nothing has changed, you can recall it. Now, at this point, you're almost done. You've gone through your 40-page or my 40-page flight checklist, the actual form that you're following. You've measured a whole bunch of different things. You have a whole bunch of data. You can print all that up into one nice, big, huge report that's 60 pages, and you give that to the client along with your bill, and they're going to go, "What's all this?" You go, "Yeah, oh, that's all the work I've been doing in here for 3 days. You've sort of been wondering what I'm doing in here, right? Right. This is what I've been doing." Now, before getting all done, though, you do want to make sure that the subwoofer splice is correct. This is a tricky thing. If you have the 4 subwoofers in the 4 corners, you will have done that during the frequency response process. But if you have one subwoofer somewhere, what actually produces a good splice to the left speaker may be different to the center and different to the right. And what I call the splice is the match in level and time and in phase. And that may take some futzing until you get that right. You may also want to check the polarity. So after you've equalized your whole system, you may actually check whether that thing we set a day and a half ago in real time, which is to set the polarity of the subwoofer to be plus or the phase at 0, can you actually improve the response by going negative? What I mean by that is if it's out of phase, if the subwoofer is not correctly phased with the speakers, there'll be a hole in the crossover. So let's say your crossover was at around 80 hertz. Wow, 2 hours and 3/4. My goodness. Right at the crossover, let's say 80 hertz, there may be competition between the subwoofer and the speakers, and you'll end up with a hole right at 80 hertz. Try flipping the polarity on the subwoofer and see if there's a flatter response. And it's really just in that third octave, usually that in that region of the crossover that you'll see that error. So after you've done all this stuff, you're going to touch up the levels. You're going to verify the balance by ear. Don't always just trust the microphone. There's a lot of ways that it can measure one thing that doesn't sound the same by ear. Really important to listen to sound cycling around with mid-band pink noise. That's that one that's only the mid frequencies. That is on the 5.1 audio toolkit. There's not a lot of other test discs that have that. You can use the internal test tones if you can trust those. You're also going to go ahead along this whole process and once again check that the frequency response, the tonal balance of all the speakers sounds reasonably identical. You can get to a point where all of the curves overlay perfectly on your analyzer, but they all sound different. And that's psychoacoustics. So you go around the room, you do left, center, right, back left, side left, top left, top right. And you do that whole cycle around, and generally while turning your head listening to the speaker, sometimes it actually helps by plugging one ear so you only hear what's coming directly to the ear, and just make sure they all sound the same. All right, are we done? No, we're not done. So there's this concept I call time synchronization. All of the speakers are typically at different distances from your ear.
Totally.
Right? Think of that slide I presented 3 hours ago.
Yeah.
And now you want to delay the nearer speakers so that their sound is arriving at the same time as all of the other speakers, as the furthest speaker. So the further speaker is handicapped. Usually the left and right speakers are the furthest away. The center is a little closer, the sides are closer, the backs are closer, the tops are closer. So what you want to do is delay everything so that they're internally digitally held until the sound of the left and rights hits you and all of the other ones hit you at the same time. Now, in the ideal world, you would just enter that by telling the surround decoder what are the distances from each speaker to the seating position. In reality, it doesn't always sound right. That's just like the frequency response business where you can get measurements that overlay completely perfectly, but don't sound right. Here you can also have arrival times that don't sound right, and that's because there could be time domain differences between the speakers. So you have different speakers in the different places, and just setting them for the same distance doesn't mean that the imaging that's coming out of those is the same. They may actually have phase rotations that are different and image differently. There could be psychoacoustic things going on in the room. There could be all kinds of different things, acoustic and psychoacoustic, that screw it up. But never mind. I was going to say an analogy, but it makes a difference when it's right. What I mean is, this is the last little tweak, and this thing is what's going to tie the whole thing together. Until you do this, you're going to have, before you do what I'm about to describe, man, I really need my hands. I'm Italian. I can't do this without video. Maybe could you turn off your video for a second, see if that helps? Yeah. So until you do this, before you do this, you will have surround sound. You'll have sounds all the way around you. You know, if you do a demo, you'll hear things going around you and all this other stuff. And then time synchronization. I'm gonna wait. Okay, I'm back. Once you do the time synchronization right, that whole surround field will be an immersive bubble where all of the speakers disappear. Everything is just a really even sound field all the way around you. You no longer hear the left, you don't hear the back left, you don't hear the tops. Instead, you just hear this entire canopy of sound all the way around you because all the sounds are properly synchronized to your seat position. And that's crucial. So turning my video back off, you can turn yours on if you want. So it makes a difference. Now, how do we do this? It's not that hard. What I like to do is to play a signal in the left and right speakers at the same time and listen for a phantom between the two speakers. And that would look like this. So play a signal, left and right signals, you should have a phantom image over here. Where do you get that signal? You can either manually plug an equal signal into the left and right channel amplifiers or their EQ, or in the 5.1 Audio Toolkit, Title 1, Chapter 20 has a test signal. It's actually mid-range pink noise that's pulsing that goes shh, 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 and you're listening for the perception that there's a speaker in the middle. If everything you've done is right, it will naturally fall there, and then sometimes it'll sound like it's a little to the right. And that's a psychoacoustic effect. And what you do if it's sounding like it's a little to the right, that means that the right speaker is getting to you a little closer. You delay that, and it may be 0.2 milliseconds is all it takes to fix that. 0.2 milliseconds, that's nothing. But sometimes that's what it takes to get that image to land right here in the So that'll make those two speakers produce really nice 2-channel stereo. Now, what about the phantom image that is between the left and center speaker? Actually, this drawing got stretched wrong. Whoa! Sorry. Let me go back up here and let me fix this live. Oh, no, I won't be able to. Sorry, this is all broken. This was actually a copy and paste. Never mind. So, apologies, this is not actually what you do. I just realized this drawing says you stay at the seating position and you play a signal that's supposed to come out of the what I call the half left, which is it's coming out of the left and center speaker at the same time, equal level. When you're sitting over here, that should produce a phantom image that's right in between the two. And usually the center speaker is closer to you when you're sitting over here in this triangle. And so that phantom image is going to be collapsed right by the center speaker. Meanwhile, it was supposed to accompany the image of a yellow Corvette starting in the middle of the screen and going off to the left side of the screen, going offside. And it hangs in the center, and it hangs in the center, and then it pops all the way off to the screen. That's what would happen if you did not fix this. And the fix is to just delay that speaker by 0.5 millisecond, 3/4 millisecond, 1 millisecond, whatever it takes to get that phantom image to be all the way over here. Okay? There is test signals for that in the 5.1 Audio Toolkit. Title 1, Chapter 22, for example, is the half left. Chapter 23 is the half right, and so on and so forth, all the way around the room. So you do a left and center, you do a left and right pair, left and center, center and right, left and side left, right and side right, side left and side right, back left and back right, all the way around in pairs. You go all the way around the room until all the phantom images between the speakers are all where you want them to be. And you can do that many different ways. Sometimes rather than use the toolkit, I actually use test signals that you can generate in pairs individually inside surround decoders or inside the equalizer. The better surround decoders give you the ability to feed test signals to multiple speakers at the same time, whatever it takes. But you're going to set the delay in the digital EQ, or if it's done by distance in the surround decoder, you can change the offsets. So if the center speaker, or if that half, this is a little brain tweezer. If you do this and you actually told the decoder, you know, my center speaker is 12 feet away from me and the left speaker is 13 feet away from me, because that's what you measured, but the image is still there. You want to delay the center speaker by some amount. If you're doing that in a digital processor, you just increase the delay. You just go to the control and you go, you know, instead of 1 foot, you go to 1.2 feet, or 1 millisecond, you do 1.1, 1.2. If what you had was a regular surround decoder where this was entered in feet, what would you do to delay that speaker a bit? This is like a little, you need a lot of coffee, brain tweeze.
There's a formula for it, and I'm drawing a blank right now, right? But there's a formula. It's at one millisecond per foot or something, right? Is it something
close enough? But in most surround decoders, that data is not put in milliseconds, it's put in feet. So what you do, what's going on here is that the sound of that center speaker, if the image is showing up too close to the center speaker, that center speaker is too close to you. Or the sound is arriving too close to you. You need to delay it. And the way you delay it is you tell the decoder the speaker's closer to you than it really is, so that it delays it even more. And that's like like you hold your head going, what? I'm freaking confused. No, it's just that you have to think about how it's considering. So the closer it is, the closer you tell the decoder it is, the more it delays it.
Well, Samir asked if that would change anything phase wise between the sub and the fronts, or no?
Well, if you don't correct it, the phase is wrong. As in what the mixer is hoping for you to hear is all these arrival times all identical. And so if you don't fix this, the individual speaker will sound just fine, but the phantom image will be at the wrong place. It's not really so much a phasing, it's going to be a location issue. So as you delay that center speaker and that image moves over there, you'll actually notice, I'm pausing because this is what makes this course take 2 days. And I love to do this with a demo. You'll actually notice this, that phantom image will go from kind of here and fuzzy, and as you move it, there's a place where suddenly, bing, it'll sound like a ball, it'll sound clear, it'll be in the right place. Why? Because now, not only is the arrival time right, but the resulting amplitude response and time response of all the speakers is totally correlated, and your brain goes, wow, that sounds exactly there. The mid-range spectrum gets clearer, everything gets better because you've finally gotten the time and amplitude response to be identical. So you could call it phase. Phase is one part of the time response. It's the whole thing, the whole impulse character of it's all correct. Now, yes, the relationship to the subwoofer may change if you had done the splice from before, so you may need to go back and check how you're interfacing the delay to the subwoofer correctly. So you're going to go through all of those speakers one at a time, and once you do this, and by the way, if you don't allocate about half an hour to 45 minutes to do this, you're going to run out of time. And by the way, your ear is different than my ear, and we're all going to agree. I mentioned this last week. It blows me away how everybody can point. Of course, you should not believe anything I'm saying. You should check everything I'm saying here. You should check yourself. But I've been in lots of rooms in which the phantom image is right here, and I go, okay, I need a volunteer. Come over here, sit down, tech, somebody else's arrow. Tell me where you hear that sound, point to it. And they point to exactly the same place.
Yeah.
And then I'll delay it and I'll ask them, keep pointing. And they'll go, the phantom image is exactly there at the same millisecond of delay that I found to be right. And I'll keep delaying it and it'll rotate all the way over there. And you can ask 3 people and they all agree, which blows me away because my ears are different to your ears and different to her ears, and everybody agrees. And that's ultimately because through fuzzy logic in our brain, we reinterpret, or we have learned to interpret imaging so we have good spatial hearing.
Good. There was just another question that came in. The phantom imaging, is the phantom image seating position dependent? Is the phantom image feeding position dependent?
Can you still hear me?
Yes.
Okay, so that zigzaggy thing is exactly what Samir is asking for, is that the phase response between isn't quite right. And as you roll through the delay, phasing in and out, and your perception of where the sound is, rather than linearly travel with the delay, it kind of goes zzz, and you kind of have to take the time to go through the whole process to figure out where's the right location. If you do your work correctly early on in checking all the things I talked about checking and equalizing and making sure that the phase rotation of all of these speakers is right, that will not happen. Instead, you have a really even displacement as you increase the delay. 3 hours. Guess what? We're almost done.
Almost there. Well,
Final check.
This is 3 hours down into 2 days, maybe even 3 days.
Yeah,
there's just so much to cover.
I've actually done this course sometimes, not just in theory, but actually with equipment where groups have microphones, just like you do an ISF course. That is a 3-day class because for people to practice it takes time.
Yes.
Okay. Final check. You're gonna actually take a break. You're gonna put all the microphones away. You're gonna get all this crap out of the way, and you're gonna start to listen to some music. The stereo should be like the left and right should produce a glorious stereo image. The bass should be well balanced. You're going to listen to films. The 8 performance goals that I'd mentioned earlier on should pass with flying colors. The dialogue clarity, the imaging, the envelopment. And chances are at this point that you're going to go, well, it all measured well, but I don't know, dialogue sounds a little edgy here, and whatever. There's not enough bass. There's too much bass. At this point, you have my permission because you've just spent 3 days getting to know this room. You have my permission to go and grab bands of EQ, levels and delays, and manually fine tune this stuff until you like the way it sounds.
Mm-hmm.
You do not have my permission to do that in the first hour. You would be going down a rabbit hole that you'll never come out of. But at this point, you've developed an intimate connection with what's going on in this room. I sound very psycho-spiritual here. You start to feel what the room is doing. And you can go, you know what, my center is just a little too pronounced. I'm going to turn it down a half a dB. And you go, yeah, that's right. A half a dB is all it took to make that room sound right. That's nothing. That's a gnat's ass. That's like 0.1% of changing the 313329 setting. Right. But that's what it takes sometimes to get it to sound just right. So now that you're all done with this, I call this the final check, because now that you're all done with this, you're going to go get the customer, you're going to give them a demo, you're going to hand them the report because you brought your printer with you, and you're going to go, I'm done, give me my money. And I highly suggest you actually collect your check then, because services are hard to collect on later on. It's just kind of how it goes.
Oh, yeah.
So quick summary of tools. Here's a bunch of things you should have with you: some test discs, some of your favorite movie and music discs, or however you get them, some big noise generators, some sine wave generators, voltmeters, multimeters, impedance meters, spectrum analyzer, sound level meters, polarity testers, oscilloscopes. I'm going through this quickly, assuming that you can always go back and look at it with the YouTube.
Yeah, and a lot of those things too, I did put links in the chat box and question box and stuff for a lot of these things. So yeah, feel free, guys, if you want to go back and check this out later and get all of the specific model numbers and stuff, go for it.
Right. So my conclusion of all this stuff is good calibration is extremely tedious. Okay, it takes a while if you want to do a good job. It's not just about tuning the EQ. It's actually about verifying everything, configuring everything, debugging everything, and the debugging could take you like days to get rid of hum and figure out why there's not headroom over here and why something is distorting over there, why there's a rattle. It takes a while. If you don't do this, you're not ending up with all the sound character. It takes a lot of practice. I've trained a number of people to do this. The first 3 or 4 times you do it, you're just going to be, your head's going to explode. There's just a lot of things to do. Just like in video, you know, you get into a flow after a while if you're ISF. I know a lot of people have gone through the ISF course, but they don't practice it, and they're like, what do I do now?
Oh yeah, for sure. That's that's common. Oh yeah.
So it takes a lot of rigor and process. I would recommend that if you're an integrator watching this and you want to do audio calibration, you either decide I'm going to do this all the time, or you hire a calibrator.
Right.
Of course, you know, shameless plug, you can hire me, but there's also a lot of other good calibrators that do audio that have gone through either my classes, the HAA classes, or other ones, or have been doing this for years. There was a SynodCon series years and years and years ago, but it is a thing you have to know. You have to just be really well practiced in it, so you don't end up falling into a trap. So now it is worth all the blood, sweat, and tears. You should be charging for this. I know people go, yeah, I'm just going to throw in the calibration. You're going to be there for 3 days.
That's a lot of labor.
If you're going to hire a calibrator, they're going to charge money. You should be charging what this is worth, which is, I can easily say that a system doubles in quality after you calibrate it.
Sure.
It's worth $500,000. You'll never get that much money, but it's worth, you know, it's worth a good $3,000 to $4,000 to get somebody out to do all of this work.
Sure.
So I usually put up my favorite references of books you can read. None of them are necessarily on calibration. Yeah, I think there's a little bit about that in Floyd's book, but anyway, so if you need to reach me, here's all my info. If you have a question that's not, you know, private and secret, I would ask you to just email Jason in the group so that everybody can see it. If there's something about a project you're specifically working on that you don't want anybody else to know, I'll take the question. Speaking of which, Jason, I'm willing to keep going if people want to. I know you said there was a bunch of questions that had.
Yeah, there was a ton of questions. I actually have something else this afternoon I've got to get ready for, so I unfortunately can't stay on. But I did record about a dozen questions from the group that were kind of very specific, and some even involved some brands and stuff. So I figure we probably leave those for offline. But I'll email everybody. I'll email Anthony everybody's questions, and then he'll answer those at his convenience. But if you guys have more questions that you want me to field to Anthony, my email address is not on the screen right now, but it's very simple. It's jason@avproglobal.com. So feel free to send me those questions. And Anthony, the next time I'll see you, we will be in our brand new AVPro South office. So I will no longer be in my bedroom. I'll be in an office. We've got some really cool plans for it, the way it's going to look, and cameras and lighting and stuff. So it should be really fun. So that's the next time I'll see you. Man, thank you so much for all this. This entire series was super helpful for me personally as an AV person and somebody who loves audio. So I really want to thank you for your time. We got a ton of really great feedback and people saying yes on doing some more advanced courses and doing some deeper dives into these things. I know a lot of folks out there, myself included, want to see REW actually in action. So we might be able to get cool here and get creative. Maybe I could set up a camera in my living room and we could just start simple and do a 2-channel and just kind of go from there. So I think certainly a conversation worth having. And if you people out there who are listening have some other recommendations or requests or things that you want to see specifically, and you're willing to spend the time with us, then certainly let me know, and we'll do what we can to kind of cater to you. These things are for you guys anyway. So again, Jason at avproglobal.com. Feel free to send me information, questions, things like that. And with that being said, that's all I've got for you guys today. Anthony, any parting words?
Yeah, a quick question. So you're going to send me the questions. I'm going to answer them. You're going to send that back out to the whole audience.
Yeah, I'll leave the names out just in case any of the questions were specific, but most of the questions were kind of brand specific. There was one question here about speaker cables and stuff. So they're all excellent questions, but we just ran out of time.
Great, wonderful. Well, so this has been a very fun series. This actually all started at the beginning of the whole lockdown. When was it? Back in March. And I've actually been doing these sessions from many different places, many different cities, many different places that I've been hiding out. It's kind of a long and funny story we'll talk about later. It's been fantastic. It's been a lot of fun.
We were doing a webinar called Building a Modern 4K Home Theater. And I was like, hey, Anthony, would you like to come in and just talk about audio a little bit? Because that's part of building a modern 4K home theater. And then you said, well, let's talk about this, but maybe in another session we can talk about this. And I was like, yeah, that was cool. Well, how about another session and then maybe we talk about this? Oh, that would be kind of cool. So we ended up just making this huge list, and here we are, like 4 months later, with probably 30+ hours of content now, which is just mind-blowing to me. And it's all up on YouTube, and people can go back and watch at their own pace and stuff. So this information is supremely valuable, and I thank you so much for your time and experience and spending the time with AVPro and with me.
Thank you. Well, again, thank you, Jason, for putting out the time to organize this thing. You guys are you sign on to the webinar. I think you've done these things. You realize how much work it is to prepare it, get it all going. Jason and I have been talking offline for hours to prepare these things. So thank you, Jason. I also want to thank again everybody at AVPro, because this has been a lot of hours invested on their part for the altruism of sharing information. Today I gave 2 plugs the entire time. Never talked about any products they make because it wasn't part of the thing. So today I gave 2 plugs for one, EDID management that AVPro does wonderfully.
Yeah.
And then for this multiplexer that they make and is available, and the rest of it has all been pure altruism, pure just for the love of it, for the love of you guys and making sure that you guys have good information. So again, thank you guys for all of your time. Because I know this has been hours and hours and hours and hours for the audience dedicated listening to me babble on about this stuff. And I'll do more if you guys want it. So see you in a camera and an earphone sometime soon.
Awesome. Well, thank you guys so much. And I think that's it for today. So we'll see you guys next time. Bye, Anthony.
All right, ciao. Signing off.